Thấy được không? Này, nào này. Okay, good morning. How is everyone doing? Can everyone hear my voice? Can everyone hear my voice? Okay, perfect. So, hope everyone is doing good. Welcome to the 22nd lecture of Dr. Hyde Step 1. Uh, in these group of lectures for this week, we are studying neurology, one of the most highest yield topics for your exam and your for the fact of your knowledge as a future physician or as a current physician. Okay. So first and foremost, we discussed a lot of high yield topics yesterday. Okay. And I would just like to spend not a lot, but close to around 15 to 20 minutes to see how much you guys remember from yesterday. Okay. And then once we have figured that out, we will be moving forward with today's lectures. Every day we target on finishing at least 10 to 12 pages, but it all depends on how much time a single page might need to be allotted because our goal is to finish first aid in 3 months. That's true. But at the same time, our goal is to finish first aid properly in 3 months. Okay. So that's that. With that being said, have you guys been solving the URL questions perfectly? Have you guys been solving URL questions perfectly? Okay. So now since we have finished a lot of topics from the organ systems, we have finished cardiovascular, we have finished GI, we have finished endocrinology, then we have finished musculoskeletal, rheumatology, and what else? I guess that's that. Okay. And that should contain a lot of questions close to around 800 to 1000. So how are you guys uh, how are you guys liking the questions on UWorld that are allotted to those topics which you have studied? Do you guys find them easy? Do you guys find them difficult? Do you guys find them and do you guys find answers or questions and comment to our discussion? Comment to our discussion. Okay, that's good to know. So what are the types of questions which you have faced that were common to our discussion? Lead poisoning. Okay, lead poisoning. And what else? Okay, so for the purpose of the new students who have joined us for this week, okay, so we will be providing a lesson plan for you all, either by today or by tomorrow. Okay, so the thing is that when we go through a very difficult topic, we do not make a proper lesson plan because we do not know exactly or confidently how many pages we can allot to each and every day. So neurology is such a topic where it will be extremely difficult for us to figure out how many pages we can allot to neurology. Despite that, our our goal for our students is that after every day you guys are done studying first aid with us for 3 to 4 hours, okay, the rest of the day should be focused on solving questions. The rest of your time of your study sessions should be focused on solving questions. Okay, this could be questions from the previous topics. This could be questions from random. Okay, but you have to solve questions. It does not matter which question bank you are using, but our preference is UWorld because UWorld is a very standard question bank because it contains all the questions that were previously used in the actual exam. Okay, you can also solve MBOSS, you can also solve K-plan. Okay, but keep in mind that solving your questions are your key or is your key to do extremely well in the exam, and reading first aid enough will not do. Okay, what is your question, Dr. Hussam? Okay, what is your question? Okay, while Dr. Hassan asks us his question, let's move forward with our discussion. Okay, so are you guys ready to do a quick recapitulation of yesterday's lecture? Very quick. Yes, you can do random in the second reset, of course. Okay, you can do random in the second reset. Okay. Okay, so let's begin with our revision and recapitulation. First of all, I would like to talk to you about some high yields, which are if you have a neural plate. Okay, if you have a neural plate and that neural plate has an alar and a basal plate, meaning the dorsal part and a ventral part, which one of the plates are involved for sensory and which one is involved for motor? Alar sensory. Okay, good. And what is the pathway for the alar plate and what is the pathway for the basal plate for activation? Okay. Okay. So next one is, do you guys remember the story of the three brothers? Okay, good. So let's share my screen really quick. Okay, so can you guys see my screen? Okay, perfect. Okay, so let's start with the story of the three brothers. So we have this first brother, second brother, third brother. What is the name of the first brother? What is the name of the first brother? Professional. Okay, so he's P. What is the name of the second brother? He's a mess up, so it's M. What is the name of the second one? What is the name of the third one? He rolls around. Okay. Okay. Then what else does what happens to the second brother? Right. Okay. What happens to the second brother? Keeps on messing up. And what happens to the third one? Meets someone, meets and meets. So now, what are the derivatives of prosencephalon, mesencephalon, and rhombencephalon? First of all, what is the derivative of prosencephalon? Telencephalon, diencephalon. What is the derivative of mesencephalon? Okay, what are the derivatives of rhombencephalon? Okay, good. Okay. Okay. Can you guys tell me from where does the microglia come from? Microglia. Where does the microglia come from? Mesoderm. Okay. What is the name of the neural tube defect in which you have failure of in which you have herniation of the spinal cord and the meninges together? Myelomeningocele. Okay. What is the name of the condition in a patient in which the brain is smooth? There's no gyri or sulci? Lesencephaly. Okay. What is the name of the condition in which the patient has monoventricle and fusion of basal ganglia on a CT scan? Okay. Okay. What is the association of Chiari-1 malformation? What is the association of Chiari-1 malformation? What is the association of Curie-2 malformation? Okay. What is the association of Curie-2 malformation? Curie-2. Curie-2 malformation. Can you guys hear my voice? Okay, what is the association of Curie-2 malformation? It's lumbosacral myelomenical. Okay. Okay. What is the presentation of a patient who has syringomyelia at the C4 to T5 level? What is the presentation of the patient who has syringomyelia at the C4 and T5 level? Loss of pain sensation and cape-like distribution of loss of pain sensation. Okay, good. Next one. Okay, next one is where does the anterior two-third of the tongue develop from? Okay, where does the posterior one-third of the tongue develop from? Okay. What is the general sensation of the anterior two-third of the tongue? General sensation. Okay. What is the taste sensation? What is the taste? Which nerve carries the taste sensation? Facial nerve. Okay. Which nerve is associated with the taste sensation of the posterior one-third of the tongue? Okay. All right. Okay. Okay. Which of the cells are important for reactive gliosis? Reactive gliosis. Astrocyte. Very good. Okay. Okay. Which of the cells are important for forming the cerebrospinal fluid? Okay, that's good. Okay, next one. Next one is, what is the name of the protein that is involved with forming myelin in the peripheral nervous system? Which one of those? Okay, okay. What is the histological appearance of oligodendrocyte? Okay. Okay, what is the name of the sensory receptor which detects pain? I mean, what is the name of the sensory receptor which detects pressure, position sense, and deep static touch? Pressure, position sense, and deep static touch. Okay. What is the name of the sensory receptor which detects slippage of objects in between the fingers? Slippage of objects. Okay. What is the name of the sensory receptor which detects dynamic and fine touch? Okay. And what is the name of the receptor which detects high frequency vibration and pressure? Okay. What are the steps of chromatolysis? 3 steps. What are the steps of chromatolysis? Cellular swelling, followed by release of ribosomes and peripheral nucleus. Okay. What is the location of synthesis of acetylcholine? What is the location of synthesis of dopamine? Okay. What is the location of synthesis of GABA, gamma aminobutyric butyric acid. Okay, comments. What is the location of synthesis of serotonin? Serotonin. Raphy nucleus, because serotonin makes you happy. Okay. Okay, next one. What is the name of the vessel that is present in between um, the skull and the dura mater? Okay. Okay, next one. Okay. Next one is the last one. That is what is the name of the circumventricular organ that is associated with vomiting in the central nervous system? Area postrema. Okay, area postrema. Good. Very good. Okay. Area postrema or OVL. Okay. Okay, OVLT is not the right answer because OVLT is not associated with vomiting. It's associated with detecting the serum osmolarity. Okay, so thank you so much and congratulations. You guys have successfully remembered most of the high yields about the last chapter that we read. Okay, so how do you guys feel? Do you guys feel confident? Do you guys feel confident? Okay, do you guys feel confident that if you guys receive questions from neurology from these chapters, you guys can easily ace it? Okay, so hopefully you guys can. Okay, so if all is well, it's 9:28 as of right now. We have most of the students. We have most of the students who have joined us already for today's lecture. Let's begin. Okay, let's begin with our regular uh, topic. That is from today. What we'll be discussing is sleep physiology. Okay, sleep physiology, and one second, please. Let me just get this in order. Okay. So another thing is, I have discussed some of the high yield topics, some high yield topics about neurology in my previous lecture. I mean, in some of my lectures on my page. Have you guys had the time to go and check it out? I have made some lectures on stroke. I have made some lectures on adult brain tumor. Okay, adult brain tumor. So have you guys had the time to go and check it out? It's completely free. It has been on my page for a long period of time. It's also there on YouTube. Okay, have you guys had the chance to? Okay, so if you guys did not have the chance to go and check it out, you guys can easily check it out after my class. Okay, after our class, you can go and check it out. And from over there, if you guys can read or understand the lectures from there, it will be easy for you to understand um, what we will be talking about in the topics. Okay, so one more second, please. Let's see why it's taking so time, a lot of time to. Okay, one second. Okay, just give me 1 second. Let me see what's wrong. Okay. So can you guys hear my voice now? Okay, can you guys hear my voice? Okay, perfect. My apologies for taking so long to start today's lectures. Okay. One of the applications were malfunctioning, but we have figured it out. Let's start with the lecture without further ado. Okay. Once again, my apologies. Okay, so it's 9:35, 9:36 as of right now, and we are starting with our today's lecture on neurology. Okay. So for this lecture, what we'll be doing is we will be starting with sleep physiology. Okay, so sleep physiology. Sleep physiology is extremely high yield for a certain reasons. Okay, because there are some pathological conditions which are associated with sleep, and what happens is you get questions in your U world or in your actual exams where they ask you what are the changes that occurs in the different stages of sleep. So sleep has four big stages, and then the third stage is divided into three more stages, and we would be solidifying all of this information right away. Okay, so before we do that, let's talk a little bit about what sleep is. Okay, so sleep cycle is basically it's regulated by your circadian rhythm. So circadian rhythm is basically when if anyone has a confusion about what the circadian rhythm is, the circadian rhythm is basically um, it's your ability of your body to detect whether it's that time period of your day where you are supposed to sleep. For example, your circadian rhythm is also known as the biological clock. Okay, it's also known as your biological clock. So basically, when you wake up in the morning and you look at the sunlight, okay, your circadian rhythm it updates itself, letting your body know that it's morning, and by then, even if you are in a deep sleep, you will be waking up. Okay, so that is how your biological clock works. And at the same time, if you go to bed every day at a certain period at night, okay, so depending on the absence of light, your body will go to sleep or it will feel drowsy. So that's what it is. So that is what circadian rhythm is. Okay, so sleep is regulated by your circadian rhythm. Okay, and the thing is, this circadian rhythm is basically driven by a nucleus in the hypothalamus. Okay, and what is the hypothalamus? The hypothalamus is an area of, is it a white matter or a gray matter? Let's see who knows. Is hypothalamus a white matter or a gray matter? Okay, so we have a lot of students who are saying white. We have a lot of students who are saying gray. So which one is it? Okay. Okay, so hypothalamus, always remember one thing that that any part of the central nervous system which contains an abundance of nucleus, okay, any part of the central nervous system which contains an abundance of nucleus, that part is basically more of your gray matter. Okay, so that part is basically more of your gray matter. Okay, so the hypothalamus is basically formed by gray matter. Why? Because it contains a lot of nucleus, but at the same time, it also contains some white matter substances. Some white matter substances. So the students who have said that they contain both are correct. Okay, but students who have also said that they contain gray matter, they are also correct because the majority of the hypothalamus is gray matter. Okay, why? Because it contains a lot, an abundance of nucleus. Okay, so the one of the nucleus of the hypothalamus is known as the suprachiasmatic nucleus. Okay, and please underline this. This is high yield because suprachiasmatic nucleus is associated with your with your with it is associated with driving your circadian rhythm. Okay, and what happens is when it's nighttime, okay, when it's bedtime, you have a nocturnal release of ACTH, prolactin, melatonin, and norepinephrine. Okay, you have the release of these four hormones, and it's not high yield that you have to remember these hormones, out of which If you have to remember one, please try to remember melatonin. Okay, please try to remember melatonin. And for the students who are staying over here in the United States, then they would know that if they go to any CVS or any Rite Aid, okay, these are pharmacies, then you guys can see over there that they sell melatonin, which is an over-the-counter drug. Okay, and melatonin is important for maintaining your circadian rhythm, and it helps with sleep cycles. Okay, so that's what it is. So what is the procedure of the suprachiasmatic nucleus? What happens is the suprachiasmatic nucleus, it releases norepinephrine. Okay, and the norepinephrine that is released, it goes to the pineal gland, and the pineal gland is involved with the release of melatonin. Okay, so the process is from suprachiasmatic nucleus. It releases norepinephrine. Norepinephrine goes to pineal gland. The pineal gland secretes melatonin. So if you ever receive a question on UWorld where they ask you where is melatonin secreted from? Is it secreted from the suprachiasmatic nucleus, or is it secreted from the pineal gland? What should be your answer? Fast, please. What should be your answer? Pineal gland. Okay, so it's released from pineal gland. If you receive a question in your URL about uh, which type of matter does the hypothalamus contain, gray matter or white matter, what should be your answer? Both. Your answer should be both. Both. Okay. So it contains both. Okay. Next is there are two stages of there are two stages of sleep. Okay, there are basically two stages of your sleep in which it is divided into REM and non-REM. REM is basically rapid eye movement, so REM, and non-REM. Okay, and what happens is if you are having a REM sleep, okay, REM sleep, that is when your body is getting ready to wake up. If that makes any sense, okay, basically meaning that right before you wake up in the morning, your body goes through REM sleep, rapid eye movement, and if you are in a deep sleep, okay, the way I like to remember is if you are in a deep sleep, everything in your body is more or less inhibited, okay, and so are your eye movements. So in deep sleep, what you have is you have a non-REM sleep. Okay, so you have a non-REM sleep, meaning that when you are sleeping, when you are in a deep sleep, or in that stage of the night, okay, when you are not aware of your surroundings at all, that stage of the night is known as non-REM, or non-rapid eye movement. So if you had to give a patient sleep medications, if you had to give a patient sleep medications, which of these stages would it affect? It's only basic knowledge after what we have discussed. Would it increase the REM sleep, decrease the REM sleep? Would it increase the REM sleep? Sleep medications. Would it increase REM or decrease REM? Okay, decrease REM. It will decrease your rapid eye movement. Okay, it will decrease your rapid eye movement by increasing your non-rapid eye movement. So basically, if you give the patient alcohol, I mean, if the patient, you will not be giving the patient alcohol. Okay, so the patient will drink alcohol. What you can do is you can provide benzodiazepines or barbiturates, and these medications, what they would do is they would decrease the REM sleep. Okay, they would decrease the REM sleep, and what they would do is they will increase your period of non-REM sleep. Okay, since they will increase the period of non-REM, they will decrease the period of REM. Okay, and also benzodiazepines. Okay, benzodiazepines, they are useful for night terrors and sleepwalking, and this is a very high yield question, although it's really easy to remember that you can give benzodiazepines to patients who are having sleep problems. But they would like to ask you a question, that if a patient comes to you with night terrors and sleepwalking, would you give them benzodiazepines or barbiturates? Okay, and the thing is, we as a whole, prescribing barbiturates have gone obsolete. Okay, so just try to remember, it's very easy, that your answer should be benzodiazepines. Okay, your answer should be benzodiazepines. Okay, so is everyone clear for this small paragraph? Is everyone clear? Okay, good. All right. Now, let's talk about this about the different stages of the sleep. So first of all, when you are going to bed, okay, the first thing is when you are just lying on your bed. At first, your eyes are open. Okay, at first your eyes are open, and at that time you are alert. Okay, and then you close your eyes and you try to go to bed and you try to go to sleep. Okay, as soon as you close your eyes, after a couple of seconds, the EEG wave in your brain changes. So first of all, when your eyes are open, the if you do an EEG right away, okay, if you do an EEG right away, I'm not sure if you guys are aware that there are different types of sleep clinics. Have you guys ever heard of a sleep clinic or seen a sleep clinic in your hospital? Okay, so okay, good. So that's what it is. So in a sleep clinic, what you would see is you would see patients who are undergoing EEG investigations while they are going to sleep. So first of all, when you see an EEG and the patients have their eyes which are open, the first frequency that would appear is a beta frequency. Okay, the beta frequency is a higher frequency with a lower amplitude. So basically, high frequency meaning that it would be like this. Okay, so high frequency, but the amplitude is very low. Okay, so this is the amplitude, and the amplitude is low. Okay, but the frequency is high, like in multiple frequencies. Okay, so that's what it is. Okay, next one is when you as soon as you close your eyes, the frequency changes. Okay, and the frequency would changes to an alpha frequency. Okay, alpha frequency. So basically, if you can try to remember that the beta frequency is a higher frequency because your eyes are open, your synapses are working more. Okay, you are more aware of your surroundings, and it will be difficult for you to go to bed. So number one is beta. Then when you close your eyes, you are less aware, and the next is alpha. Okay, and then after you close your eyes, you enter the period of non-rapid eye movement, and then the non-rapid eye movement is again divided into three stages. So the first stage is a lighter sleep. Okay, and that waveform is known as theta. That waveform is known as theta, and and the second one is N2 sleep. Okay, so it's N2, and when you have a stage of N2, that's when your patients have a deeper sleep. Okay, that's when your patients have a deeper sleep. That is when the sleep cycle it changes to sleep spindles and K complexes. That's when it changes to sleep spindles and K complexes. Okay, and what happens during deeper sleep is when the patient is in a deeper sleep, there is bruxism. Okay, so bruxism is basically tooth grinding. So you will see a lot of your patients. If you examine them, if you see that your patient is undergoing bruxism, meaning that they grind their teeth, you have to realize that that patient is in the N2. Okay, that patient is in the N2. Okay, and the way I try to remember from the tooth grinding is basically you have from the word tooth, TWOTH, tooth for N2 or stage two. Next is stage three. Stage three is this is the deepest stage of the non-REM sleep. Okay, and stage three is important because stage three is that period of the night when that patient goes, when the patient can have sleepwalking, bedwetting, and sleepwalking, bedwetting, and night terrors. So basically, you have three problems at three. So let's do a small recap before we move forward. First of all, what is the first step? Eyes are open, you are alert. The wave is beta. Next is your eyes are closed. The wave is alpha. Then you have non-REM sleep in which you have stage N1, N2. N1 is a lighter sleep in which the wave is theta. In N2, you have a deeper sleep. Okay, in N2, you just try to remember the word tooth for two. So tooth for two. So meaning that bruxism occurs at two, and the wave is now sleep spindles and K complexes. Okay, so the thing is, only knowing the names of the waveforms are enough. You don't have to identify them in the EEG form. Okay, so understanding the names are or keeping in mind just the names are enough. Okay, after that, you have stage three. Stage three is basically you have three problems at stage three. What are the three problems that occur at stage three? The number one problem is sleepwalking. The number two problem is night terrors. And the number three problem is bedwetting. And the waves is delta. Okay, do not worry. We will try to solidify the waves with a mnemonic. So Let's just read this through and then we can solidify it. After that, you enter a period of REM sleep, and this is the last stage of your sleep, which is around 25%. Okay. And what happens during this part is this is when your body is getting ready to wake up. So, right before you wake up in the morning from tomorrow, you will realize that if you have any dreams, you can realize that those dreams usually try to occur right before you wake up. Okay. And dreaming is basically that period of your REM sleep, so REM sleep. Okay. So what happens is you have a patient who has loss of motor tone. Okay. And then at that point the brain starts getting activated again because your body is getting ready to wake up, right? So your brain uses more oxygen. Okay. And then it also uses more acetylcholine to increase the transmissions. Okay. And then the REM is that part when you start dreaming, start having nightmares. Okay. And you have memory processing functions. So what happens is if you get a question that what is the stage at which night terrors usually occur, night terrors, and what is the stage at which nightmares? Okay, keep in mind that nightmares and night terrors are completely different things. What is a night terror? Does anyone have any idea what a night terror is? What is a night terror? What is a night terror? Does anyone have any idea? Yes or no? If no, I would make you understand right away. Nightmare and night terror. What is the difference? Okay. Okay. So basically, nightmare. Okay. So if you have a nightmare is basically a bad dream. Okay. So basically, it's a bad dream. So for example, nightmare is basically that period of your dream in which you see things which you do not want to see. Okay. And it makes you extremely uncomfortable and upset. Okay. Maybe you can see a dream about monsters or see a dream about about someone you love passing away. Okay, so that's a nightmare. So night terror is another sort of an N3 problem in which what happens is you have a patient who is having sleep, who is having episodes. Okay, so there are episodes of screaming, fear. Okay, and what happens is the patient screams during the sleep. The patient moves. Okay, then the patient usually wakes up. Okay, and then this is followed by extreme tachycardia and sweating. That's what night terror is. So night terror is a more what is basically it's a more deeper form of a nightmare. Basically, in night terrors, what you have is you have a patient who is screaming in their sleep, okay, moving around in their sleep, and then the patient usually wakes up, okay, and then the patient has extreme tachycardia, sweating, right? So that's what night terror is. So you have to understand the difference between a nightmare and a night terror because both of them are occurring at different stages of the sleep. So REM is that part where you get nightmare, and N3 is the part where you get night terrors. So please do not mix them up. Okay, please do not mix those up. Okay, next one is, and the waveform that you see again in REM sleep is your beta sleep, is your beta waveform. Okay, so before we move forward, let's solidify the EEG changes. Okay, so whenever first aid provides a mnemonic themselves, you have to realize that these are extremely high yield because they will come in your exam. So the mnemonic which first aid used is bats drink blood. Okay, bats for, so bats B, okay, A T. So bats drink blood. Bats drink blood. Okay, so that's what they use, and that's what they used. And the reason they use this is because, so for the first one, you have the first stage of your sleep in which your eyes are awake. Okay, and that part is when your brain is undergoing beta waves. When you close your eyes, okay, when you close your eyes and you are when you close your eyes before going to the lighter sleep or N1, your EEG changes to alpha waves. Okay, and then after that, at N1 you have theta waves. At N2 you have sleep spindles and K complexes. Okay, K complexes. At N3 you have delta waves, and at REM sleep
you have beta waves again. Okay, so that's what it is. And please use the mnemonic which Freud has given you. So that's what it is. Okay. Okay. So right now, the next one is what's happening over here is that you have extraocular movements due to activity of the PPRF. PPRF is paramedian pontine reticular formations, and we will be talking about this in a while. So, what is PPRF? So, basically, PPRF is that part of your, I mean, it's the part of your central nervous system, which is associated with moving your eyes in the same direction, either left or right, at the same point. Okay, and that's that. Oh, another one is the REM sleep occurs every 90 minutes, and the duration increases throughout the night. Okay, so first of all, after we have understood this whole table, we have to address what are the questions that you will receive from this table. The number one question that you will receive from this tables are what are the different types of EEG forms at the different stages of the sleep. Okay, so in order for you to answer that perfectly, you have to understand the mnemonic. Okay, that is your number one question. Number two question is what is the stage at which night terror occurs? The stage is N3. Okay, what is the stage at which nightmares occur? Nightmares occur at REM sleep. Okay, and you have another changes, that is what are the changes in sleep that occurs in elderly patients, and what are the changes in sleep that occurs in a patient who has depression. Okay, so first of all, in a patient who is an elderly, okay, so an elderly patient, what they have is they have decreased REM sleep time. Okay, they have decreased REM sleep time, and they have decreased N3. Okay, so what's going on is the patients who are elderly. Okay, so basically what happens is um, basically what happens is in elderly patients, okay, due to senile reasons, okay, senile or elderly reasons, what they have is they have depletions of neurotransmitters very fast. Okay, so you need acetylcholine for your REM sleep to occur, and since there is decrease of uh, since there's some amount of senile degenerations of the neurotransmitters in old age, that is one reason why there is decrease of REM sleep. Okay, what happens is in elderly patients they have more non-REM sleep. So elderly patients, although they have a difficulty in going to sleep, but once they do start sleeping, you would realize that your elderly grandmothers or your grandfathers, okay, they can go and they can sleep for a long period of time in that deeper sleep. Okay, they will have less amount of REM sleep. They will have less amount of REM sleep, meaning that you wouldn't see a lot of your grandparents coming to you and talking about their dreams. Okay, so they don't dream as much. Why do they not dream as much? Because they have decreased REM sleep time. Okay, so if you have to remember this, if you have to remember what happens in the sleep, write this down, that grandparents do not dream. Okay, write this down, grandparents do not dream. And if you can write, if you can remember that your grandparents, they do not dream, then you can easily answer that if they do not dream, their REM sleep time is less, and N3 is also less. So because in N3 you have night terrors, and in REM sleep you have nightmares, so both of them decreases. So both of them will decrease. If you have a patient who has a depression, okay, so if you have a patient who has depression, then patients who are undergoing depressions have neurotransmitter abnormalities, right? Okay, they have decreased amount of serotonin, and then a lot of the other neurotransmitters are not balanced. And the reasons for that being is that they have increased amount of REM sleep time. So your patients who has depressions will have increased REM sleep time. So what would happen is you would realize that patients who are depressed, if they go to sleep, they do not wake up in the morning feeling refreshed. Why do they not wake up in the morning feeling refreshed? Because most of their stage of the reason being that most of the stages of their sleep were REM sleeps, meaning that they were having rapid eye movement throughout the whole sleep. Okay, and the latency, meaning the REM latency. Latency is basically meaning that if, let's say, you have a period of REM sleep, then you have a period of normal sleep, then you have a period of REM sleep again. So this is the time period at which the REM sleeps occur. This is known as latency. Okay, so if you have higher latency, that means REM sleep will occur less. Okay, but if you have lower REM latency, meaning that if you have REM sleep, okay, then you have a normal sleep, and then immediately your REM sleep will start again, and then you have a normal sleep, and then immediately your REM sleep will start again. So what happens is your REM latency decreases and your REM sleep duration increases. Okay, and at the same time, N3 also decreases over here. So that's another thing. That's one thing which you have, which they have in common with the elderly patients. That in elderly patients and in patients who are undergoing depressions, both of them have decreased N3. But the main problem is between the REM sleep time. Okay, and they will have repeated nightmares and early awakening, meaning that they can wake up really early in the morning. Why? Because they are undergoing REM sleep, and when the body undergoes REM sleep, it prepares itself for waking up. Okay, so that's what it is. Okay, and another one is, what is the change of the patients in narcolepsy? Narcolepsy is basically that condition in which the patients have increased amount of incretins or hypocretins in the CSF. And what happens is the patients they have uncontrollable sleep in daytime, very simply put. And if that's what it is, then in narcolepsy, what happens is there are patients who have decreased REM latency. At the same thing which happens in depression, that is the REM sleep occurs at a faster period of time. So that is basically the changes in narcolepsy. Okay, and with that being said, we have finished the sleep physiology. Okay, so latency is, what is latency? First of all, let's say you have a period of REM sleep. Okay, then you have a period of normal sleep. Okay, then at one point you have a period of REM sleep again, and that happens every 90 minutes throughout the whole sleep, as a matter of fact, according to your text. Okay, so let's say this is your normal patient. Okay, how about you have one patient in whom the REM sleep is occurring right like this, then a shorter period of normal sleep, then immediately you have REM sleep again, then you have another short period of normal sleep, and then immediately you have REM sleep again. So this increased period of REM sleep at a shorter duration means that the latency at which the REM sleeps are occurring is decreased, meaning that they're occurring more throughout the whole night. So you have REM sleep, REM sleep, REM sleep. So that's exactly what you mean by latency. Latency is basically the space of periods in which the REM sleeps occur. Okay, the space at periods at which the REM sleeps occur. Okay, okay. Okay. So why does the REM sleep time decrease in elderly? The REM sleep time decreases in elderly for a multiple of reasons. Well, one of the reasons which were described in UWorld, they did not describe the reasons why they're occurring. They just stated that they are occurring. Okay, but one of the reasons were disruptions of neurotransmitters due to senile degenerations. That was one cause. Okay, so understanding the reason why they're occurring is not as high yield for your exam, but remembering that they do occur is extremely important, and that's why we used the mnemonic that grandparents do not dream. Grandparents do not dream, and that will help you remember that elderly patients have decreased REM sleep, and if they have decreased REM sleep, then they will dream more. I mean, they will dream less. I'm sorry, they will dream less. Okay, so that's what it is. Okay. Okay, so can I ask one doctor what are the different EEG waveforms before I move forward? Is anyone confident to answer? Can I get some answers from some of the students who have never participated, who would be kind enough to participate today? Anyone? What are the different stages of the sleep? What are the EEG forms? Okay, okay, so let's talk to Dr. Otero and Dr. Maheshwari. Okay, so let's see what Dr. Otero is. After that, we can move forward really quick. We don't have a lot of time today. Okay. Okay, so can you hear my voice?
Yes, doctor. Good morning.
Okay,
Good morning,
wonderful.
everyone.
So, would you be kind enough to tell us what are the EEG waves you would expect to see in your patient whose eyes are awake, whose eyes are open?
Beta wave.
Beta wave, that is correct. What do you expect to see in your patient in which their eyes are just closed?
Alpha wave.
Alpha, that is correct. Next one is what is the waveform that you see in the N1 of non-REM sleep?
Theta
Theta wave,
wave.
that is good. So thank you so much, Dr. Otero. And
Thank you. My pleasure.
you are absolutely welcome. Okay. Next one is Dr. Maheshwari. And Dr. Maheshwari, let's see where you are.
Yes, doctor.
Okay, perfect. So what is the waveform that you expect to see in your patient who is undergoing N2?
Sleep spindles and K complexes.
Okay, please do not move your pages of the book. Okay, try to answer from your knowledge. If you can, that's great. If you cannot, that's also great because if you cannot remember, we will help you remember. Okay, don't look at your book. What is the waveform that you would see in your patient who is undergoing N3?
Who is undergoing M3 delta?
Delta wave, that is correct. And what is the waveform that you would expect to see in your patient who is undergoing REM sleep?
Beta waves.
Beta waves. Okay, thank you so much for participating. Okay, perfect. Okay, so that's what it is. Okay, so we spent quite an amount of time studying sleep. Okay, but it's important. So that's that. And then once again, can anyone tell me what are the changes of sleep that you would see in a patient who is an elderly patient? What stage of sleep and you memorize all this information. So basically, if you're asking me which stage of sleep you can memorize all this information, it's basically your which stage, which stage. It's your REM sleep. Okay, REM sleep is that period of time when you can process your memory formations. Okay, okay. So basically, if you have an elderly patient, you will have decreased REM and decreased N3. Okay, perfect. Okay, so please remember what are the changes that you would expect to see in your patient who is an elderly and who has depression, because these are actual questions in your U world, and high possibility you will also receive them in your actual USMLE Step 1 exam. Okay, next one. Okay, next one. Next one is hypothalamus. Okay, so what is hypothalamus? Hypothalamus, once again, is a collection of nucleus. It's made up of gray matter mostly, and it also contains some amount of white matter substances. And the biggest thing that the hypothalamus does is that the hypothalamus, it maintains homeostasis. What is homeostasis? Homeostasis is basically, I'm pretty sure you guys know, that homeostasis is the maintenance of a constant balance of all the things that is going on in our body. Okay, so homeostasis is the maintenance of the constant balance of everything that goes on in the body by the mechanism of positive and negative feedback. That's what homeostasis is. Okay, and what are the basic functions of a hypothalamus? The hypothalamus is used for regulating TANHATS. TANHATS is basically thirst, functions of adenohypophysis or anterior pituitary, neurohypophysis or posterior pituitary, which releases hormones. And then it also regulates hunger, autonomic nervous system, temperature, and sexual urges. So that's what your hypothalamus is. So once again, hypothalamus is thirst, and then adenohypophysis, neurohypophysis, hunger, ANS, temperature, and sexual urges. That's what it is. But if you have to ask me whether you guys need to remember the functions of the hypothalamus, then my answer should be no. Okay, so will you get excuse me will you get questions about the functions of hypothalamus? My answer is no, but it's still good to understand what the hypothalamus does. Okay. Okay. So basically, since I told you guys before that the hypothalamus, it contains nucleus. Okay, it mostly contains a lot of nucleuses, and the nucleuses which they contain, they help regulate the different functions that we just talked about. Okay, so what we would do is before we address all the information over here in the table, I would like to go back to one of my diagrams once again. Okay, let's see. Shapes. Okay. Okay, so this is okay, so this is easier. Okay, 1 second. And then okay, just give me 1 second, please. Okay, let me just figure out, help you guys remember the diagram and the nucleus very easily. Okay. 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 So basically what the hypothalamus is that the hypothalamus, it contains a lot of nucleuses. So the first nucleus which the hypothalamus usually contains is, so first of all, the hypothalamus. Let me show you a diagram of how it looks. I'm pretty sure you guys already know how the hypothalamus looks. Okay, so the hypothalamus is basically this part. Okay, this is the part where the hypothalamus is usually present. And the hypothalamus basically is once again a collection of gray matter and white matter together, mostly gray matter because it contains a high amount of nucleus. And for the purpose of your USMLE, you need to remember all the nucleuses and the functions. Okay, so we would be doing that through this rough diagram. Okay, so if this is the breakdown of this diagram, if this is a breakdown of this one, okay, so in this diagram of hypothalamus, first of all, you have a lateral nucleus. Okay, so first of all, you have a lateral nucleus, and the lateral nucleus of the hypothalamus, okay, what it does is the lateral nucleus is involved for hunger. Okay, so lateral nucleus is involved for hunger. Okay, and what happens is let's say you have you guys heard of Chinese dish called lo mein or lo mein? Anyone? Okay, so we have one physician over here, so who has heard? So okay, two. So okay, so two doctors knowing out of 32 is not enough. Okay, so let's talk about chicken legs. Okay, I'm pretty sure you guys have had fried chicken. For all the students who are vegans or vegetarians, I apologize. Okay, but for the students who are not, have you guys had KFC's fried chicken legs? Okay, yes. So I'm pretty sure we have no physician over here who is a carnivorous and has not had a chicken leg in their life. So chicken leg. Okay, so think about your chicken leg. That is your lateral nucleus, the leg, chicken leg. So L for the lateral nucleus, and L makes you hungry. So whenever you see a chicken leg, you get hungry. Okay, so chicken legs, hunger. That's what it is. Okay, now the next one is so if this is the lateral nucleus. Okay, if this is the lateral nucleus, then if this is the lateral nucleus, then this part, okay, this whole part of the hypothalamus is the medial nucleus. Okay, medial, or what we would like to say is this is ventromedial. Ventromedial. So you have some questions where they mention ventromedial. You have some questions where they just mentioned medial, and medial is enough. Okay, and medial is basically that part of the hypothalamus which is involved with satiety. Okay, so what is satiety? Satiety means that you are satisfied with the amount of food that you have intaken. Okay, satiety. So, and you are satisfied and you are no longer hungry, or you are no more hungry. So that's what it is. So you have one lateral for chicken leg. Whenever you see a chicken leg, you get hungry. And whenever you eat a massive amount of food, okay, M for massive. Whenever you eat a massive amount of food, you get satisfied. So ventromedial for satiety. Okay, so ventromedial for satiety. Now, you have another group of nucleus. Okay, so this should have been a 3D picture. Okay, so but obviously I am not that good at drawing. Okay, so please try to imagine a 3D picture of the hypothalamus. This is the anterior nucleus. This is the anterior nucleus, and the anterior nucleus of the hypothalamus is involved with, okay, air conditioning. Okay, A for air conditioning. Air conditioning, what this does is air conditioning is a sympathetic response. Okay, why is so basically the anterior nucleus is involved for cooling your body. Okay, so if your body gets heated up, then the anterior nucleus gets activated and it causes cooling of your body. And this cooling of your body is a parasympathetic response. And why is cooling a parasympathetic response? Because we all know that sympathetic is basically fight or flight. In order for you to fight or in order for you to flight, which is a sympathetic response, your body needs to be heated up. Okay, it's only basic knowledge. And if you are resting or if you are calm, if you are just lying down watching a movie, okay, your body, it remains cool. Okay, it calms down, it remains cool, and that is a parasympathetic response. Okay, at that time your body has no reason to get sympathetically activated because you are in not are you nor are you ready for a fight or flight. That's what it is. Okay, so anterior nucleus is for cooling and anterior A for AC. AC is your air conditioner. Okay, posterior. Obviously, if your anterior is for cooling, then your posterior is for heating. Okay, so the posterior is for heating your body, and heating is once again, if anterior is a parasympathetic response, and posterior is a sympathetic response. Okay, so if anterior is AC, then posterior is basically heating. And if you have these already done, so once again, chicken leg for hunger, massive food. I mean, massive diet or massive amount of food will make you satisfied. So satiety, anterior for AC, cooling, posterior for heating. That's what it is. And if that's all that, so basically, if you have these nucleuses in mind, then you have mastered most of the high yield nucleuses, because the next of the three nucleus are very easy to understand. The next nucleus which you have is suprachiasmatic nucleus, and I'm pretty sure you guys already know. What is the suprachiasmatic nucleus involved for? We already talked about this. You are a vegetarian, so I apologize, Dr. Maheshwari. Okay, for you, let's say lentils. Okay, so whenever you see lentils, you get hungry. Okay, L for lentils. Okay, and for all the carnivores over here, L is for chicken legs. Okay, okay, and basically circadian rhythm. That's correct. Okay, so chiasmatic nucleus is associated with circadian rhythm. Okay, okay, perfect. And that's what it is. Okay, and the next one is you have supraoptic and paraventricular nucleus. So you have supraoptic and paraventricular, and we already talked about the supraoptic and paraventricular nucleus in endocrinology. Okay, what is the supraoptic and paraventricular nucleus associated with? Supraoptic and paraventricular nucleus associated with. We already talked about endocrinology. That is correct. Supraoptic and paraventricular nucleus is associated with ADH, and oxytocin. Okay, ADH and oxytocin, that's what it is. And we have another group of nucleus, that is a last nucleus. That nucleus is your preoptic nucleus. That is your preoptic nucleus. Okay, and preoptic nucleus is basically, this is a very, very primitive nucleus. What do you mean by a primitive nucleus? Primitive nucleus means that over time, when during by the process of cellular proliferation and evolution, okay, our characters have changed, and we have learned different mechanisms based on the environment which we have grown up in, right? So that's that. But there is one nucleus in the brain which is extremely primitive, that was present from the Homo sapiens timings, and that nucleus is a preoptic nucleus, and that nucleus is basically your body's ability to regulate thermal changes. So it's used for thermoregulations. Okay, so thermoregulations, and it is also used for your sexual behaviors. Okay, so sexual behaviors, which are your mating tendencies. Okay, so it's a very primitive body response. So thermal regulation is a very primitive body response, and sexual regulations or sexual urges and behaviors are primitive body responses. And the hormone that is involved with the release of that is involved for these two are basically GnRH. Okay, gonadotropin releasing hormones. And I'm pretty sure we already talked about this once when we were discussing endocrinology. Once again, to all the students, for all the students who have missed out on endocrinology, do not worry. We will be taking the lectures again. Okay. But for the students who were present during our endocrinology lectures, then you guys should know that we already talked about these things. Okay, so does this make the whole table easier? Does this make the whole table easier? You want to take a picture of the diagram? Okay, a lot better. Okay, so next time what you could do, okay, so I will show you that picture, no problem. Next time, what do you do? If you want to save yourself time for reviewing that table, all you have to do is look at the diagram which you have drawn, or look at this diagram which I have drawn, or but I would suggest you guys draw it yourself. Okay, instead of taking a picture, you can take a picture right now because you guys do not have time to draw one. But whenever you get the time, draw this small diagram over here. This will help you answer most of your questions from the hypothalamus. Okay, so before you guys start drawing, now let's talk about some destruction. So what would happen if you destruct a nucleus? Okay, so if the lateral nucleus, meaning the chicken leg or the lentils, whenever you see chicken leg or whenever you see lentils, you get hungry. If this nucleus gets damaged, okay, if this nucleus gets damaged, okay, now let's say you damage this nucleus, okay, let's say you damage this nucleus, let's say due to trauma or ischemia, okay, and what would happen is, would you be hungry ever? Would you ever be hungry? No. Okay, so you will not be hungry anymore. So you will not be hungry. So what would happen is the patients will be anorexic. Okay, anorexia. So that is known as anorexia. So your patients will be anorexic. And what would happen is, let's say you are a researcher in a lab. Okay, you are a researcher in a lab, and you have lab mouses. Okay, and you destroy the lateral nucleus of a lab mouse. Okay, you would realize that the lab mouse will die by not eating, and they will not be hungry. Okay, so the same goes for patients. Okay, so what happens is, either you can remember that chicken leg or lentils make you hungry and destruction of the lateral nucleus makes you lean, or there is another mnemonic. Okay, then the mnemonic is lateral injury. Okay, I'm pretty sure first aid already used this. Lateral injury makes you lean, makes you lean. Okay, so lateral injury makes you lean. Okay, lateral injury makes you lean. Either you can associate this, or what I would suggest is you can learn any one, because learning both of these mnemonics can confuse you. Okay, so I would suggest is try to remember chicken leg or lentils for hunger. That whenever you see them, you get hungry, and if you have destructions, then you will not be hungry. As simple as that. Okay. Next one. Next one is if you have destructions of the ventromedial nucleus, will you ever be satisfied by your food? No. You will never be satisfied. You will keep on eating, 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 because no matter how much you eat, your body is not satisfied. So what would happen is that the patients will get obese. Okay, you will get obesity, and the patients will get extremely massive. So either you can use lateral injury makes you lean, and M for ventromedial injury makes you massive, or you can also use the mnemonic that massive food intake makes you satisfied. And if you have destructions of the ventromedial nucleus, you will never be satisfied in your life and you will become obese. Okay, next one. Okay, excuse me. Next one is if you have a patient who has destructions of the anterior nucleus, vice versa, your body will have a difficult time cooling, meaning that the basal body temperature will rise. Okay, will be always high. Okay, and if you have a patient who has destructions of the posterior nucleus, vice versa, your body will have a difficult time getting heated up, and you can get hypothermia. That's what it is. Okay, so that's all you have to know. And if that's all, then let's go back to our text to see if everything is well. Okay, if we have discussed everything. Okay, so basically what's going on is they talked about the lateral nucleus. We also talked about the lateral nucleus. What we failed to mention was the lateral nucleus is stimulated by ghrelin and leptin, and it's inhibited by leptin. So ghrelin and leptins are hormones. Okay, so ghrelins and leptins are hormones. Does anyone know where ghrelin is secreted? Where is ghrelin is secreted from? Where ghrelin secreted from? We already talked about this once. We already talked about this once. Okay, it's secreted. It's okay. So Dr. Hossam, who has said that it is secreted from the stomach, he is absolutely correct. Okay. And where is leptin secreted from? Leptin, leptin or leptin, adipocytes. That is correct. You have ghrelin and leptin. So ghrelin, this does is ghrelin. Okay. So this is what you can remember. Ghrelin makes you hungry. Okay. Okay. So ghrelin makes you hungry. Okay. So how does ghrelin make you hungry? Ghrelin goes and stimulates the lateral nucleus, and the lateral nucleus makes you hungry, as simple as that. So if you can remember that ghrelin goes and stimulates the lateral nucleus, then obviously leptin, which is the antagonistic hormone, will go and inhibit the lateral nucleus and stimulate the medial nucleus, which makes you satisfied or it causes satiety. Okay. So does that make it easy for you to remember that ghrelin makes you hungry? Okay, so you can remember that ghrelin makes you hungry. Then ghrelin go and stimulate the lateral nucleus, and leptin will go and stimulate the ventral medial nucleus. Okay, let's see here if we have skipped out on anything. Okay, so suprachiasmatic nucleus for circadian rhythm, we talked about this. Uh, Posterior nucleus for heating. Okay, we also talked about that. Supraoptic and paraventricular nucleus synthesize ADH. Okay, and preoptic nucleus. Okay, so what is the disease that occurs when you have destructions of the preoptic nucleus? Okay, so the preoptic nucleus is basically it is associated with your releasing of GnRH, okay, your gonadotropin releasing hormone. And this gonadotropin releasing hormones, what they do is this: if there's failure of GnRH production, um, what happens is these neurons, they usually migrate to the olfactory pit. And if there is failure of this GnRH producing neurons, there is a condition that is known as Kallmann syndrome, which is associated with infertility and smell changes. Okay, the patients cannot smell. And what we would do is, instead of reading about Kallmann syndrome right now, we would be talking about Kallmann syndrome in the future when we talk about the neuropathologies. So let's keep this for the future. Okay, for right now, just try to remember the name. That is, if you have destructions or damage of preoptic nucleus, then you can come up with a disease. That disease is known as Kallmann syndrome. Okay, that's that. So another thing, let's see. Okay, so you have another area over here. Okay, and you have another area over here. We already talked about this yesterday. That is OVLT. OVLT is organum vasculosum of lamina terminalis. Okay, so it's a circumventricular organ. Okay, so what are circumventricular organs? These are the parts where there's a physiological break in the blood-brain barrier, which allows it to detect changes in the blood. And what changes does this detect? It detects osmolarity, serum osmolarity. Okay, and hypothalamus also contains a very high yield high yield circumventricular organ, and that organ is known as area postrema. So basically, two high yield circumventricular organs. One of them is OVLT, which detects osmolarity. Another one is area postrema, which detects toxic or toxins in the blood for vomiting. Okay, so with that being said, we have covered all the informations from hypothalamus. Okay, and there is absolutely not one thing that is unimportant, meaning everything from this table is very important. You will receive a lot of questions from the hypothalamus. So basically, you have to solidify this information, and the best way to do that is with the help of our mnemonics and the diagram. Okay, that's that. Okay. Okay. So do we have any confusion or questions regarding hypothalamus? Do we have any questions or confusions regarding hypothalamus? Okay, so who is confident to answer some questions about hypothalamus? Um, we would appreciate physicians to participate who have never participated before. Okay, this will allow you to be confident with your answers in the future. Okay, so who is confident to do a fast recap, and then we can move forward. Okay, why do I want you guys to do it right now? Because I want you guys to use the rest of your day solving questions. So whatever you have to learn and memorize, you have to do it right away during my lecture. Okay, so we have one doctor, Dr. Iman, and then who else? Is there anyone else? Dr. Maheshwari, you have participated before. I'm just seeing. Okay, so Dr. Maheshwari again. Okay, no problem. So let's start with Dr. Iman, number one, and then we can go to Dr.
Yes.
Maheshwari. Okay, let's see where you are. 1 second. Okay. Would you be kind enough to tell us what does the lateral nucleus of the hypothalamus do?
Hunger.
Hunger. Okay. What is the ventromedial nucleus associated with?
Satiety.
Okay. And what is the anterior nucleus associated with?
Cooling. Parasympathetic.
Okay, perfect. And what is the posterior nucleus associated with?
Sympathetic and heating.
Perfect. Thank you so much. That's what it is. And next one is next one is, let me see where Dr. Maheshwari is. Okay. Okay. So would you be kind enough to tell us what does the suprachiasmatic rhythm do? Suprachiasmatic nucleus do?
Maintain circadian rhythm.
Okay. What is the function of supraoptic and paraventricular nuclei?
Supraoptic secretes ADH and paraventricular secretes oxytocin.
Okay. And what is the function of preoptic nucleus?
Thermoregulation and sexual behavior.
Okay, perfect. Thank you so much. So that's exactly what it is. Okay, so that's what it is. And okay, so you have a question where you are asking whether if your ventromedial nucleus is destroyed, you can eat anything and everything and you will not vomit because you are not satisfied. So vomiting and satisfaction is completely different. Okay, so you can be unsatisfied, but you can still vomit because if the stomach loses the capacity to hold food and you keep on eating, there will be vomiting by reflex stretching mechanism. Okay, so you will undergo regurgitation by reflex stretching mechanism. So you will still vomit, but you will still not be satisfied. Okay, so vomiting will still occur, but satisfaction will not be there. Okay, that's that. Okay, next one. Next one is what we have to do is we will study about the thalamus. Okay, we will study about the thalamus, and the thalamus is an extremely important topic for your exam. Okay, the thalamus is an extremely important topic for your exam. You will receive a lot of questions from the thalamus, and once again, like the hypothalamus, which remains beneath the thalamus itself contains a lot of high yield nucleuses. Okay, but the difference between the thalamic nucleuses are the thalamic nucleus. These are relay nucleus. So what do we mean by a relay nucleus? Okay, so let's say first of all, let's say once again, bad drawing. Okay, give me 1 second. Okay, so let's say this is your brain. Okay, this is your cerebral hemispheres, which contains your motor and sensory areas. I would write sensory and I would write motor. Okay, I'm just giving you guys a breakdown of what the thalamus is. Okay, and then you have this structure over here. This structure roughly put is your thalamus. Okay, and then you have your spinal cord over here. Okay, then you have your spinal cord. Okay, over here. Okay, and what is basically the thalamus? So the thalamus is basically what's happening with the thalamus is basically the relay center, meaning that all the information that is coming from your body, okay, all the information that are coming from your body uh, for basically the sensory information, okay, every sensory information, like let's say if someone touches you, let's say if you move your joint in a certain way, let's say you feel temperature, you feel changes in temperature, you feel pain, every sensory information in your body, what this will do is at first they will come to thalamus in any one of the nucleus. Okay, so the thalamus has VPL, VPM, Okay, lateral medial geniculate bodies and ventral lateral nucleus. So basically, even your even your vision and your hearing. So even those sensations, because those are modified sensations, even those sensations will come to your thalamus, and they will come to your thalamus. And when they come to your thalamus, from your thalamus, they will go to the sensory cortex. So from there, they will go to the somatosensory cortex, or if it's a if it's a visual sensations, then they will go to the occipital lobe, to the visual cortex. And if it's a auditory sensation, then they will go to the auditory cortex and the temporal lobe. Okay, so basically, do you guys understand what the thalamus is? The thalamus is basically your relay station, meaning that, let's say if this is a train, okay, the train of sensations, which is going all the way to the brain. Before it reaches the brain, it makes a stop at the thalamus, it waits, and then from the thalamus, it goes to the brain. Okay, and that's it. And why does this happen? This happens basically because your brain needs to identify and address the proper sensory information, instead of identifying and addressing every sensory information, because the brain is a highly active organ, so it can detect almost anything and everything that's going around in your presence, right? So if you do not want to exhaust your brain all the time, if you do not want to put unnecessary informations in your brain, you have to put all the sensory informations through your thalamus, and your thalamus will decide which of these sensations are important for your brain to receive, and which of these informations is important for your brain to not receive. Okay, so that's that. So are you guys clear on what thalamus is? For all the students who are not cleared what thalamus is? Okay, okay. So neurology is a very complicated topic. Okay, most of the structures that we are studying were not put a lot of emphasis on in our bachelor's. Okay, we were just told the names and everything. Right now, what we have to do, we have to go deeper into these structures. So before we do that, we have to touch the basics once again. Okay, so that's so it can reject some sensations. Well, rejection will not be the correct word. The correct word should be modify. Okay, the correct word for the thalamus is modifications, not rejections. Okay, they will not reject any sensation. They can modify a sensation. Okay, yeah. Okay, right. So they can modify a sensation. So that's what your thalamus is. So once again, the thalamus is a relay station. Okay, that's what it is. Okay, so sometimes it takes me a while to organize my thoughts, and I just go through periods of breaks. Okay, so my apologies. All right. Okay, so once again, let's draw a picture for our friend thalamus, right? Like the one we did for hypothalamus. Okay, the one we did for hypothalamus. Okay, and this is roughly a circle for the hypothalamus, for the thalamus once again. Okay, and okay, and what I would like to do is, okay, okay, all right, okay. Okay. So this is a very rough diagram, 2D diagram of your thalamus. Okay, and with the help of this diagram, hopefully we can solidify all the informations about the nucleuses and what are they associated with. Okay, so the first nucleus of the thalamus is ventral posterolateral. So the first nucleus is a ventral posterolateral or a lateral nucleus. Okay, so ventral posterolateral. Okay, so basically what we would be doing is we would just say lateral. Okay, so lateral nucleus of the thalamus. Okay, let's just write VPL. Okay, ventral posterolateral, because if I write lateral, you'll confuse it with hypothalamus. Okay, so VPL. Okay, so ventral posterolateral. Okay, so that's what it is. And the ventral posterolateral nucleus, okay, this is associated, the ventral posterolateral is, so this is associated with the same senses that is beginning with the initial. So we are going into the mnemonic section of our studies. So VPL is associated with VPL, meaning that VPL is associated with vibration. VPL is associated with pain. VPL is associated with pressure, okay, pain, pressure. Then VPL is associated with proprioception, okay. And if I'm not wrong, VPL is also associated with light touch. VPL is associated with light touch, okay. So VPL for vibration, pain, pressure, proprioception, light touch. That's what it is. So if that's the case, if that's what's happening with the lateral ventral posterior lateral nucleus, can you guys tell me which of the columns of the spinal cord? Okay, we know that the spinal cord has columns. We have the dorsal, and then we have lateral columns. Okay, which of the columns of the spinal cord are involved with providing input to the ventral posterior lateral based on the senses I have just mentioned? Dorsal column and medial lemniscus and spinothalamic tract. Also, spinothalamic tract, meaning the lateral spinothalamic tract, is associated with, and the anterior and lateral is associated with. I'm sorry. The lateral spinothalamic tract is associated with pain, and the dorsal column medial lemniscus system is associated with vibration, pressure, proprioception. Okay, and the anterior spinothalamic tract is associated with light touch. So, basically put, the VPL receives its input, the spinothalamic tract, and the dorsal column medial lemniscus system. Okay, and where do they provide the input? The thalamus. So this is basically your normal sensation. So vibration, pain, pressure, proprioceptions, and light touch are your normal sensations. And so all of these normal sensations will go all the way from the thalamus to the sensory cortex, or as we like to say, primary somatosensory cortex. So primary somatosensory cortex. Okay. So next time what happens is, after we are done with today's lecture, okay, let's say you meet someone, okay, let's say you go and meet someone, and when you shake their hands, okay, I do not know how much of handshaking is happening in different countries based on the pandemic. Okay, so let's talk about fist bumping. Okay, so let's talk about the fact that, let's say you fist bump someone, okay, and that sensation which you feel the next time when you do that, immediately try to realize that that sensation is basically your sensation that is traveling from your hands. Okay, so if you fist bump with someone, that sensation is traveling from your hands all the way up. Okay, and if it's a crude touch, it will go to the anterior spinothalamic tract or the spinothalamic tract all the way to which nucleus? To the VPL. From the VPL, it goes all the way to the somatosensory cortex. Okay, so next time when that happens, if you think about it once, then you will never forget how the thalamus is involved and how that sensation is traveling all the way from your body, from your peripheral tissue to the brain. Okay, so this is how your sensation travels. So that's that. So VPL. Okay, next one is VPM. Next one is VPM. Okay, ventral posteromedial. Okay, and VPM is associated with identifying the sensations of the face. Okay, and we know that the face, okay, if this is your face over here, okay, okay, this patient with a long nose. 1 second. Okay, and that's what it is. Okay, so this is the patient's eyes. Okay, the patient's nose. That's what it is. Okay, so if you have a patient like this, okay, and what is the sensation of the face from over here? What is involved with this? Which nerve is involved with the sensation of the face from over here? CN5. So basically CN5 meaning V1, okay, then we have V2, and then we have V3, okay. So this is involved with ophthalmic, maxillary, and the mandibular division of the trigeminal nerve. Trigeminal nerve is a cranial nerve, right? It's a cranial nerve. So what's happening is the facial sensations are carried by trigeminal nerve, okay, trigeminal nerve. So the VPM is associated with VPM, okay, What is M is basically, if you can try to realize that M is your M for makeup. Okay, M for makeup. So if you have to put makeup, where do you put it? You put it on your face, right? So that's what it is. Okay, I know I know nowadays a lot of people use makeup like anywhere else in the body, but primarily, where do we put makeup? We put makeup, not not me. Okay, so I do not put makeup. But people who put makeup, okay, people who put makeups, they put their makeup on their face. That's what it is. Okay, so mostly all our female physicians over here, okay, who are involved with using makeups. Okay, why am I saying makeup so many times? Because I would like to associate the fact that M is for makeup and M is also associated with VPM, M for medial, so ventral posterior medial. Okay, so ventral posterior medial nucleus is your nucleus to detect the sensations of makeup. Okay, and makeup goes on the face, and face is associated with trigeminal nerve, and all of these sensations from the face will go straight to your VPM. And in the same way, let's say instead of the fist bump, let's say this is your face now. Okay, the facial sensations will go all the way through your spinal cord and then to the thalamus, and then in the thalamus it will go to the VPM instead of the VPL, and then from the VPM it will go to the somatosensory cortex. That's what it is. Okay, so M, do not forget VPM, M for makeup, and makeup goes on the face. That's what it is. Okay, and that's that. So if you get a question about which of the nucleus of the thalamus is involved with detecting the informations of the trigeminal nerve, the answer is ventral posterior medial nucleus. Ventral posterior medial nucleus. Okay. Okay. Now you have two more nucleus. Okay. Now you have two more nucleus. You have a lateral geniculate nucleus, and you have a medial geniculate nucleus. Okay. The lateral geniculate nucleus. Okay. The lateral geniculate nucleus. So lateral, L for lateral and L for light. L for lateral and L for light, and M for medial geniculate nucleus, and M is for music. Okay, M is for music. So if lateral geniculate nucleus is for light, then we can understand that easily that the lateral geniculate nucleus is receiving visual informations. Okay, visual informations through which nerve? That is CN2, right? Optic nerve, chiasma optic tract, and information from optic nerve, chiasma optic tract goes to the lateral geniculate nucleus, and from the lateral geniculate nucleus, okay, so from the lateral geniculate nucleus, so let's say these are your eyes over here, okay, and they're seeing a vision. This will go all the way to the thalamus, and in the thalamus, right now, they will go to the lateral geniculate nucleus, and from the lateral geniculate nucleus, they will go to the visual cortex. That is your primary visual cortex. The primary visual cortex is usually in the calcarine sulcus. Okay, so we'll talk about them later, but just try to understand that don't make the mistake of mentioning the fact that visual sensations will go to your somatosensory cortex. So that is impossible. They will go to your visual cortex. Okay, that's what it is. The same way this happens, you also have M for medial geniculate nucleus. M for medial geniculate nucleus. M is for music, and music is your hearing sensations. Okay, so you hear something. Let's say you hear a music. Okay, let's say you have your AirPods on. You're listening to some songs, and those things and those informations are going to your thalamus. Okay, and in your thalamus, they are going to the medial geniculate body, and from the medial geniculate body, right, they will go to the auditory cortex. The auditory cortex is, sorry, that's the parietal lobe. Auditory cortex, they will go to the temporal lobe. Okay, so goes around here. That's what it is. And that's that. So the next time when you are, let's say you are at the gym working out, okay, you're listening to music, take 1 second to recall and review how that music is reaching your brain. Okay, and then you can identify easily that, okay, M is for music and M is also for medial geniculate nucleus, and that is a nucleus that is present in my thalamus. And right now the music is traveling from my ears all the way to the thalamus, and then it will go to my primary auditory cortex that is in the temporal lobe. Okay, so if you can identify that once, or try to think about these things in your practical life, okay, all of these information will be incorporated very easily. Okay, that's what it is. Okay, so auditory cortex. Okay, another nucleus is, I will not draw that nucleus right now. Okay, So another nucleus is ventral lateral nucleus. Another nucleus is ventral. It's a comparatively lesser high yield nucleus. Okay, ventral lateral. And the ventral lateral nucleus, it receives information from the cerebellum, okay, and the basal ganglia. Okay, so let me break it down. Okay, let me break down what this means. Okay, so just give me 1 second. First of all, we know that the cerebellum and the basal ganglia. So let's draw this small circle for cerebellum, and let's draw basal ganglia. So let's say this small circle is your cerebellum and your basal ganglia. This is your higher center. Okay, this is your higher center. And what would happen is, okay, before I draw that, 1 second. Okay, let's say this is the thalamus. Okay, let's say this is the thalamus, and this is your cerebellum and basal ganglia. Okay, okay, and this is your higher center, the cerebral cortex. Okay, right now. Okay, so we're talking about the function of the ventral lateral nucleus, and in order for us to understand the ventral lateral nucleus, we have to master a basic concept. Okay, what is the basic concept about cerebellum and basal ganglia? To all the students who know this already, congratulations. To everyone who doesn't, this is for you. Okay, so what happens is, let's say this is your hand. Okay, okay, let's say this is your hand. Okay, so right now, if you are sitting on a table, if you're sitting on a table, uh, even though you cannot see your hands for some reason, or let's say that this is your hand on your table. Okay, okay, and this is the part of your hand that you can see. Okay, you can see this part of your hand, but you cannot see this part of your hand. But you cannot see this part of your hand because this is out of your visual radius. Okay, but what's happening is, from this part of your hand, you have proprioceptive receptors, or joint position sensing or changing receptors, which has provided input all the way to your cerebellum and your basal ganglia. Okay, so next time when you want to move your if you want to move your elbow right now, okay, your higher center has to identify what the position is. Okay, and the thing about cerebrum, okay, so the cerebral hemispheres, the thing about these centers are they cannot directly detect the position of your joints, because the joint position and senses are detected by your cerebellum and basal ganglia. This information is provided to your cerebellum and your basal ganglia, which once again modifies that information. Okay, so it modifies that information. After it modifies that information, it sends the information to thalamus. Once again, why do they send the information to the thalamus? Because the thalamus is the relay station. Okay, the relay center. So in the thalamus, they use this ventral lateral nucleus. They use this ventral lateral nucleus, and from this ventral lateral nucleus, this information then goes to the motor cortex, not the sensory cortex. They go to the motor cortex. Why do they go to the motor cortex? Because this motor cortex is associated with moving this elbow, right? So in order for this cortex to provide the appropriate information to move this elbow, it has to know what the position of the elbow is. Okay, and that is why this information is provided all the way to your motor cortex and not your sensory cortex. And then your higher center, okay, your higher center makes a calculated decision that, okay, now I will move this elbow in a certain position. Okay, because now I have understood what the position of this elbow is. And then based on the surroundings, okay, based on the surroundings, because if your cerebral hemisphere tries to move this elbow really fast somewhere left or right, up and down, you might hurt yourself. Okay, so this makes a very calculative decision, and then it moves the elbow. Okay, and in order for that to do that, once again, the cerebellum and the basal ganglia will send information to the cerebral hemispheres through which nucleus? The nucleus is ventral lateral nucleus. Okay, so I know the reason why I broke this down. It's because a lot of students, they get confused about why they are sending the information to motor cortex and why are they not sending the information to the sensory cortex, because the thalamus is involved with sensory sensations and not a motor sensation. Okay, so this is the whole breakdown of what's happening. That why ventral lateral nucleus is associated with sending the information to the motor cortex. So once again, this is somewhat of a sensory information too, because it's sending joint informations, right? But the only difference is instead of sending the sensation to the somatosensory cortex, it is sending the information to the motor cortex. Okay, so did you guys understand about the ventral lateral nucleus? Ventral lateral nucleus. Okay. Does anyone have any confusion regarding ventral lateral nucleus? Okay, good. Okay, so that's what it is. Now, let's go back to our text. Let's see what our text says. Okay, this is not the text. Okay, so let's look at our text. So first again, so once again, we have the ventral posterolateral nucleus. Okay, and as we said, this is detecting vibration, pain, pressure, proprioception, light, touch. Okay, we forgot to mention temperature, so but it also senses temperature, and uh, it's easy to understand. It detects temperature because it's involved with the input from spinothalamic nerves, spinothalamic tract. So spinothalamic and dorsal column medial lemniscus system. That's what it is. Okay, and then you have ventral posteromedial. Ventral posteromedial once again is face. Okay, they use the same mnemonic. I use the same mnemonic as first aid. So makeup goes on the face. That's what it is. So ventral posteromedial for the facial sensations. Then lateral for light, primary visual cortex, medial for music, or auditory cortex, and this medial genicular nucleus, it receives information from the superior olive and inferior colliculus of the tectum. Okay, superior olive and inferior colliculus of the tectum are basically structures which are involved in the auditory pathway, and we will be talking about the auditory pathway in details in the future, after which all of this will be clear. Okay, but for now, try to understand they're receiving input from the superior olive and inferior colliculus. And then you have the ventral lateral nucleus, which is receiving input from the cerebellum and basal ganglia, and they send the input to the motor cortex. That's what it is. Okay. Did everyone understand the nucleus of hypothalamus? Okay. Okay, so who is confident to answer questions regarding hypothalamus? Yusuf. Okay, so Dr. Yusuf, what is your email address once again, please? Dr. Yusuf. Dr.
Yes. mazar m8@gmail.com.
Okay, are you using the are you the one with M's creation? Is that you?
Yes, yes, yes.
Oh, perfect. Okay, so we got a little bit confused.
Uh-huh.
Okay, so would you be kind enough to tell us what is the ventral posterolateral nucleus associated with?
It's it receives the input from the spinothalamic tract
Okay.
and the posterior column,
Okay.
dorsal column,
Okay.
and excuse me.
What are the sensations which the nucleus detects?
Yes. Yeah, pain, temperature, vibration, proprioception, and pressure.
And pressure. That's correct. Thank you so much.
And
Next.
to reach the primary somatosensory area.
Okay,
Cortex.
perfect. Okay, so the next nucleus is the ventral posteromedial nucleus, and what sensations do they detect?
Detect all the face sensation, the same sensation, vibration, pain, pressure from the face.
Okay, perfect. That is correct. And
The taste, and go to the primary somatosensory cortex also.
cortex. Okay, perfect. Thank you so much, and thank you for participating, Dr. Yusuf. And let's go to who else? Okay. Oh, we have Dr. Hossam over here. Okay, so Dr. Hossam, let's see where you are. Let's see where Dr. Hossam is.
Yes, doctor, I'm here.
Perfect. Yes. Okay. So what is the sensation detected by the lateral geniculate nucleus?
Lateral, so light, so it's vision sensation.
Okay. And what is the sensation detected by the medial geniculate nucleus?
Auditory sensation.
Auditory sensation. That is correct. And I'm pretty sure you would know that the destination is visual cortex for vision and auditory cortex for hearing. Okay. So that's what it is. Okay. Thank you. That's all. Thank you.
Welcome.
Okay, so that's what it is. And then once again, the ventral lateral nucleus is the lesser high yield nucleus. Ventral lateral nucleus detects position changes from the joints, and they send it through the cerebellum, from the cerebellum to the motor cortex. Okay, that's what it is. Cerebellum to the motor cortex. Please don't confuse VPL with VL. Okay, ventral posterior lateral is completely different from ventral lateral. Ventral posterior lateral is detecting the changes from the spinothalamic and dorsal column, and the ventral lateral is detecting changes from the position senses that are sent through the cerebellum and basal ganglia. Okay, and now if you ask me what are the questions I might receive from thalamus, okay, my answer is there are hundreds of questions which you can receive from hypothalamus and thalamus, and there is no obvious one question. Okay, there is not one thing that is unimportant over here. So everything is important for the hypothalamus and thalamus. So there's not one thing you can leave out. So that the question for which what questions are being received from these two tables, it's a very broad question, and the answer is anything is a question over here. Okay, so try to read anything and everything. That's why we took our time, tried to understand, try to make you guys understand the whole thing, broke it down into little pieces, so that it's easier for you to recall and review the whole thing. Does this make the tables easier? Does this make the tables easier? Perfect. Okay. Okay. So would you guys be interested in taking a break right now, or and then moving forward? Okay. It's already been close to around 2 hours. Okay. Okay. So after we come back, we will be talking about limbic system and cerebellum, dopamine, and our dopamine pathways. Okay. So that's that. Okay. So we would take a break for 10 minutes. Okay.
Okay, so is everyone back from the break? Okay, so let's wait for 2 minutes to see if everyone is back from the break. From the break, please let me know. Okay. So far, how are you guys finding studying neurology? Do you guys find it difficult? Is it easier? Okay, that's easier. So good to know. Thank you so much. Okay, good. So let's start with the next one, that is limbic system. Okay, so is everyone back from the break? Can everyone hear my voice? We are going to discuss a pretty important topic right now. Okay, so is it important to know which tract transfers which signals like group touches? Yes, we will discuss about the tracts. So do not worry. Okay, we will break down tracts. Okay, perfect. Okay, so we will be discussing about the limbic system. Okay, the limbic system. And what is the limbic system basically? The limbic system is basically your collection of structures which are involved with your emotion, memory, behavior. And once again, the limbic system, it contains structures which are very primitive. So these are primitive structures. So these primitive structures are responsible for primitive functions. So these are primitive functions of a human being in general. Okay, these are not modified uh, these are not modified modern functions. So these are a very primitive function of a human being, which is feeding, fleeing means running or escaping danger, okay, fighting, okay, feeling, and sexual urges once again. So that's what it is. So the famous five F's, okay, so the famous five F's for feeding, fleeing, fighting, feeling, and sexual urges. So that's what it is. So that's that. So it's responsible for all the F's and sexual urges. That's what it is. And the question that you will receive from the limbic system are, what are the structures of the limbic system? Okay, so the first structure of the limbic system is hippocampus. Okay, the next structure of the limbic system is amygdala. Okay, the next structure are mammillary bodies. Then you have anterior thalamic nucleus. Okay, then you have anterior thalamic nucleus. Okay, anterior thalamic nucleus. And then you have cingulate gyrus, and entorhinal cortex. Okay, and entorhinal cortex. That's what it is. So the mnemonic is basically, if you guys remember, the small bone of the hand that we talked about. We talked about our bone hamate. Okay. So if you can also remember hamate for the limbic system, hopefully you can remember all the structures for the limbic system. The hamate is basically H for hippocampus, A for amygdala, M for mammillary bodies, AT for anterior thalamic nucleus, and E for entorhinal cortex and cingulate gyrus. So if you can remember hamate, okay, so try to remember hamate, and you can easily remember all the structures of the limbic system and the functions of the limbic system. Okay, you do not need to understand what the functions of these systems are in details. Okay, that is beyond the scope of USMLE step 1. Just understanding that which of the structures make up the limbic systems are enough. Okay, and over here they are showing you that you have the hippocampus in A. So this is your hippocampus. Okay, and you have the
cingulate gyrus over here. Cingulate gyrus are shown by the yellow, the yellow arrows. And we would be solidifying this information when we study about the MRI and CT scans in the future. So that's that. Okay. So once again, what are the structures of the limbic system? What are the structures of the limbic system, please? A4, hippocampus, A4, amygdala, M for what? Mammillary bodies. Then AT4, anterior thalamic nuclei, E4, 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 entorhinal cortex and cingulate gyrus. So EC for entorhinal cortex and cingulate gyrus. So please try to remember the word hamid. Okay, the hamid for limbic system. Okay, that's what it is. Okay, the easiest way that you can recall the structures of the limbic system is by using the word hamid. Okay, okay. Next one is what we are going to do is we are going to study the dopaminergic nerves. We are going to study the dopaminergic pathways. Okay, the dopaminergic pathways. So basically the dopamine pathways are basically you have four major pathways out of which you have the mesocortical pathway, mesolimbic, nigrostriatal pathway, and the tuberoinfundibular pathway. So you have these four pathways over here. Okay, and the fact that these pathways are involved with the negative, positive, extrapyramidal, and the prolactin pathways are extremely important. And that is one of the broad spectrum knowledge that you have to have about the pathways of the dopamine pathways. Okay, so though the understanding the dopamine pathway is important because one of a very high yield disorder, that is a Parkinsonism disease, is associated with dopaminergic abnormalities. And another thing is these pathways can be altered with the use by certain drugs, okay, out of which antipsychotics are your number one drugs, which alters the dopaminergic pathways. And that's that. Okay, so your first pathway is the mesocortical pathway. The first pathway is mesocortical pathway. And mesocortical pathway is what they do is that they decrease they decrease activity. Okay, so mesocortical pathway is associated with activity. Okay, and mesocortical pathway, what happens is if there is damage of the mesocortical pathway, then there's decreased activity. Okay, decreased activity, and we can break down the whole pathway step by step. Okay, but what that will do is that will put extra information for your understanding, and that is not needed for your exam. What you have to know is only the fact that mesocortical is associated, abnormalities of mesocortical pathways associated with decreased activity, and abnormalities of the mesolimbic is associated with increased activity. So based on this decreased activity and increased activity, you have some symptoms. That is, if there is a problem with the mesocortical pathway, the patients get lethargic, the patients have no energy, meaning anargia, and the patients lack spontaneity. There's lack of spontaneity, that's what it is. And all of these are known as negative symptoms. Negative symptoms mean symptoms which are downers meaning which brings a person down. Okay, and that's that. So you will receive a question in your URL where they will ask you which pathway is associated with negative symptoms, and mesocortical, try to remember that mesocortical is associated with decreased activity. Mesolimbic are your positive symptoms. Okay, so what are the positive symptoms? Positive symptoms are when a person is hyped up, or it's an upper are basically like symptoms which are involved with, let's say, increased amount of delusions, hallucinations. The patient is active, the patient cannot sleep for a long period of time, and we know the disease, for example, let's say bipolar disease, they go through a period of they go through an episode where they have an episode of positive symptoms like these, right? And even patients who abuse certain drugs, for example, let's say you have patients who abuse cocaine, or you have patients who abuse methamphetamines, or even let's say PCP, phencyclidine, and these are the patients who show signs symptoms of excess positivity, meaning that they show signs symptoms of delusions, hallucinations, and the pathway that is involved with such altered activity is your mesolimbic pathway. Mesolimbic pathway, and the easiest way that you can identify mesolimbic for increased activity is mesolimbic over here, as we can see that the limbic system is associated with all the positive sign symptoms, meaning that feeding, fleeing, fighting, feeling, and sexual urges are basically your activity has to increase, right? You have to be in increased, you have to have a lot of energy to perform these tasks. Feeding, fleeing, fighting, you need to have a lot of energy to perform these tasks, and these are your sign symptoms of your positive these are the positive sign symptoms, and these symptoms are associated with the limbic system, and that's how you can easily associate that the mesolimbic, it has the word limbic in it, and limbic is your positive symptoms pathway. Okay, so if there is a problem with the mesolimbic pathway, then you can get positive symptoms. Okay, so next time what you could do is, if you come across, let's say, a friend or someone okay, and they are showing sign symptoms of delusions, hallucinations, this and that, the pathway that you can think about is that they have an altered activity in the mesolimbic pathway. Okay, next one is nigrostriatal pathway. Nigrostriatal pathway. What is the nigrostriatal pathway? This pathway is associated with extrapyramidal symptoms. Pyramidal symptoms are, pyramid is basically the motor tract in which you have the normal functions of the muscles. And then if you have extrapyramidal symptoms, meaning that there is muscular contractions that is outside of the pyramidal tract, okay, these are known as extrapyramidal symptoms, and these contain some abnormal movements such as dystonia, akathisia. Okay, we will learn about these movements in the future. Parkinsonism, in which you have uncontrollable movements. Okay, tardive dyskinesia. Okay, so these are the extrapyramidal symptoms, and the pathway that is associated with extrapyramidal symptoms is nigrostriatal pathway. That's that. Okay. Another pathway is tuberoinfundibular pathway. Tuberoinfundibular pathway, I'm pretty sure we have already studied about this when we were studying prolactin, is that the tuberoinfundibular pathway abnormality is associated with increasing in prolactin activity. And once again, we have known from our previous knowledge in endocrinology that if prolactin increases, the patient gets gynecomastia, galactorrhea, right? Infertility. So that's what it is. So these are the 4 pathways of the dopamine. Okay, and each of these pathways are questions. These are questions. So what is the question? The question is basically, which pathway is associated with negative symptoms? Your answer is mesocortical pathway. Which pathway is associated with positive symptoms? And when you think about positive symptoms, you think about increased amount of bodily energy, and you need the energy to do feeding, fleeing, fighting, feeling, and sexual urges. So positive for limbic, and your answer is mesolimbic system. Okay, which pathway is associated with extrapyramidal symptoms? And your answer is a nigrostriatal pathway. And once again, prolactin for tuberoinfundibular pathway. Tuberoinfundibular pathway. Okay, and over here, when we study schizophrenia, we will see that you will have patients who has these positive symptoms, that is the symptoms of delusions and hallucinations. And the major ways that we can target this is by antipsychotics, which help stabilize the mesolimbic pathway. That's how you can target schizophrenia, treating schizophrenia. Okay, so are you guys clear about the pathways and the questions that you will receive from the pathways? Are you guys clear? Okay. Okay. So let's ask some questions. Okay, let's ask some questions. Is anyone confident to answer the questions about the pathways? Is anyone confident to answer the questions about the pathways? Tuberoinfundibular pathway. So the last one was tuberoinfundibular pathway. Tuberoinfundibular pathway is the pathway which is associated with maintaining your prolactin level. Okay, so if there is abnormality of the tuberoinfundibular pathway, your prolactin level will increase. If you have prolactinemia, okay, you will get galactorrhea, gynecomastia, and infertility. So your question of a new world will ask you that they will ask you that you have a patient who has gynecomastia, galactorrhea, and infertility. Which of the following dopaminergic pathways are abnormal or unstable? And your answer is tuberoinfundibular pathway. That's it. Okay. So, okay, so who is ready to answer some questions about the pathways before we move forward? We do not have a lot of time, please. Anyone? Anyone? Do we have anyone who is confident? Yes, Dr. Hossam, thank you. Okay, so we have Dr. Hossam. Okay, let's see where you are.
Yes, doctor, I'm here.
Okay, perfect. So which of the pathways are abnormal for negative symptoms?
Negative mesocortical,
Positive?
mesolimbic,
Okay, prolactin?
tubuloinfundibular,
Okay, extrapyramidal symptoms?
nigrot striatal pathway.
Okay, that's it. That's all I wanted to know. Okay, that is all that you have to know. You are welcome. And thank you for participating all the time. And so that's what it is. So that's all you have to basically know from this table over here. Okay, so that's all. Okay, so let's move forward. Okay, let's move forward. Let's move on to cerebellum. Okay, let's move on to cerebellum. So what is cerebellum? Once again, cerebellum is your, what the cerebellum does is that the cerebellum, it receives, as we told you guys before, do you remember how we talked about the fact that we talked about, let's go to this, where is our image? Okay, it's not over here, 1 second. Okay, this one. So do you guys remember how we talked about the fact that your cerebellum and basal ganglia, that it's involved with detecting changes in your joints, right? And then it sends information to the brain, and then the brain modifies the information to send it back to the motor, and that's exactly how the cerebellum works. So that's what it is. Okay, so now we're going to learn a bit more about the cerebellum. Okay, and the cerebellum is basically they modulate, okay, or they modulate meaning they modify the movement, okay, and they help in coordination and balance. Okay, so they help in the coordination and balance, and the cerebellum is very easy to identify over here. As you can see that this portion of the patient's MRI is the cerebellum. Okay, and input meaning information which the cerebellum is receiving. Okay, so the cerebellum, it receives information from the contralateral cortex. Okay, 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 so there are, okay, so once again, let's say this is the cerebellum. Okay, and okay, this is one cerebral hemisphere, and this is another cerebral hemisphere. Okay, so the cerebellum, okay, so you have the divisions of the cerebellum. Okay, so this part of the cerebellum will receive information from the contralateral. Okay, so this part of the cerebellum will receive information from this part of the cerebrum. Okay, what informations are they receiving? Once again, let me break it down. Okay, okay, let me break it down easily so you would know. Once again, let me draw this hand. Okay, okay, then let me draw this brain, and let me draw the cerebellum. Okay, keep in mind I did not draw the thalamus. Okay, the thalamus should have been here. I'm skipping it out because all I want to do is focus on these three structures. Okay, so first and foremost, your higher center, that is your cerebrum. Your cerebrum always has a tendency of making extra impulses. Okay, so in a patient who does not have a cerebellum, if a patient does not have a cerebellum, they cannot modify the information from the brain. So what would happen is, let's say you have a glass of water. Okay, you have a glass of water over here. Okay, and this is your hand. Okay, 1 second. And let's say that this is your hand. Okay, and you want to receive this glass of water, and you want to do it appropriately. You want to make slow, sustained movement. Then you want to do a proper grip around the glass of water, and then you want to pick it up, and then you want to drink it. Okay, so if you do not have a cerebellum, what would happen is your brain would send extra information to your head. And right now, this patient who does not have a cerebellum, what he would do is, instead of grabbing the glass of water in a slow, sustained movement, he would just smash through the glass. Okay, he would just smash through the glass, and he would break the glass down, or he would just push the glass away, and he will have an extremely difficult time making that slow, sustained, calculative movement. Why is that happening? That is happening because your central nervous system is lacking the center which modifies the information of the brain. So let's say the brain wants to go and grab that glass of water. Okay, so it will make extra. Okay, it will make extra impulses, increase extra impulses. Okay, if your cerebellum was intact, okay, if you had an intact cerebellum, what your brain would do is, at first the brain will send the impulse, okay, to the cerebellum. That, okay, so let's say the brain is talking to the cerebellum. The brain is telling the cerebellum that, okay, I want to move the hand to go and grab the glass of water. So the cerebellum is like, okay, then send me the impulses. So the cerebrum is sending the impulses. Then the cerebellum goes like, he goes like, okay, the impulses which you are sending is extreme, okay, and you will knock the glass of water down. So what you need to do is, I need to inhibit you. So the cerebellum will inhibit some impulses and it will modify it. Okay, and how can the cerebellum modify this information? The cerebellum can modify this information because the cerebellum already has knowledge about where the hand is. Because if you guys remember, we talked about the ventral lateral nucleus. And through that ventral lateral nucleus, the cerebellum is always updated that where the hand is, due to the fact that there is presence of proprioceptive receptors, right? So the cerebellum knows exactly how much impulse the hand needs in order to grab the glass of water. Okay, so the cerebellum will go like, okay, I know exactly how much impulse this hand needs to grab the glass of water. So all of this extra impulses which you are sending is not correct. You will knock the water down. Then the cerebrum, that is your higher center, will agree to it. He will be like, okay, send me the modified impulses. So the cerebrum will send the modified impulses, okay, by tweaking and tweaking some of the impulses. And then your cerebrum will send that modified accurate impulse. Then your cerebrum will send that modified accurate impulse to go and grab the glass of water successfully in a slow, sustained manner, and then pick it up and drink it. Okay, so did that make sense to everyone? Okay, now do you understand what the cerebellum is? Cerebellum. Now do you understand what the cerebellum is? Okay, so do you guys realize how much activity goes on in your brain to perform a task that is so small? Okay, to perform a task that is so small, but there are millions and billions of impulses that is going around your brain, okay, in order for you to perform that task perfectly. That's the whole point of the cerebellum and the basal ganglia. Okay, so right now, if you have a patient who has problems with the cerebellum, okay, right now, if you have a patient who has problems with the cerebellum, that's why you see patients who are having movement disorders. That's why you see patients who are having movement disorders, because that movement is the result of the extra impulses which are being sent from the higher centers to the muscles without having it modified. Okay, so you see chorea, then you see athetosis, then you see movement disorders such as dysdiadokinesia. Okay, and these are all extra movements which the brain is sending before the impulse got modified by the cerebellum. Okay, so is everyone clear? Then we would move forward. You guys clear about the cerebellum? Okay, so that's what it is. Okay, so right now, okay, so good. So now the input of the cerebellum. So basically the cerebrum, once again, this is your cerebellum and this is your brain. Okay, and this is your, let's say this is your hand. Okay, so right now the cerebellum was receiving input, meaning that the cerebrum, do you remember how we were talking about the fact that that your higher center was talking to your cerebellum, that he was saying that, okay, I want to move that glass of water. This talking is done from the contralateral side. Okay, so this part of the brain is the one which does the talking. So this is an input, and this input, this talking is done via the middle cerebellar peduncle. This is the structure through which the cerebrum talks to the cerebellum by the middle cerebellar peduncle. Okay, and do you remember how we also talked about the fact that the cerebellum was talking back to the brain saying that, okay, the impulses that you have sent are not correct because I know exactly what the position of this joint is. And how does the cerebellum know the position of this joint? That's due to the fact that it's receiving information from the spinal cord through this hand by the inferior cerebellar peduncle. And the best part is it's ipsilateral, meaning it's receiving information from the contralateral part of the brain, and it's receiving information from the ipsilateral part of the head. Okay, so let's say the right-sided cerebellum, okay, will receive information from the right-sided hand, and it will also receive information from the left side. This is the right side. They will receive information from the right hand by the inferior cerebellar peduncle, inferior cerebellar peduncle. And if they had to receive information from the brain, then they would receive information from the left side of the brain via the middle cerebellar peduncle, MCP. Okay, middle cerebellar peduncle. That's what it is. Okay, so that's how they receive the information, and then they modify it. Okay, and then they modify it. Okay, and after they modify, okay, they do an output. Okay, they do an output. And do you remember how we talked about the fact that the cerebellum was talking back to the cerebrum? The cerebellum was telling the cerebellum that, okay, the impulses that you are sending me is too extreme. You will knock the glass down. I need to modify it. And he modifies it. And after he is done modifying it, he sends an impulse back to the cerebrum, that is the higher center, by the superior cerebellar peduncle. And for the output tract, we would take blue one. Okay, okay. And for this one, what they're doing is after they're modifying this information, they are sending this modified information back to the brain by the superior cerebellar peduncle, by the superior cerebellar peduncle. That's what it is. And now the brain is ready to make that calculated decision and send the impulses to the hand, and from the hand it goes and then it grabs the glass of water. Okay, so once again, okay, last time, this is extremely high yield because you will receive a lot of questions from this physiology. Okay, once again, the brain, okay, we will talk about this in terms of a story. Okay, our story is grabbing the glass of water. Okay, so the story is the brain has decided that it will grab a glass of water. So the brain is talking to his little brother cerebellum. Okay, cerebellum is smarter. The brain is asking the cerebellum that, okay, I want to move this glass of water. And the cerebellum, okay, and the brain does that via the middle cerebellar peduncle. Okay, so the brain is talking to the cerebellum via the middle cerebellar peduncle. Okay, and then the cerebellum, okay, which is the little brother who is smarter, he is telling the cerebrum that the impulses that you are sending is extreme because I have already received information from the hand, and the hand has sent out this information via the spinal cord through the inferior cerebellar peduncle. And then the cerebellum is telling the cerebrum that I will modify your information. And after I can modify the information, you can send the proper impulses. So the cerebrum, okay, he agrees. And after the cerebellum modifies that information, the cerebellum sends that modified impulse via the superior cerebellar peduncle. Okay, is that understood? Is that understood? Is that understood? Did you guys understand? Okay, and am I going too slow? Am I going too slow? Okay. Okay. Is the pace of the lecture good? Because I am taking some extra time trying to break down the whole basic concepts of cerebellum, cerebrum, okay, so that it's easy for you to answer the questions. Because if you have a strong concept and a strong basic, then you can easily identify the pathologies. Okay, so did you understand how the cerebrum and the cerebellum, they're talking to each other constantly? Yes, okay. So once again, how is the cerebrum talking to the cerebellum? How is the cerebrum telling the cerebrum that I want to move the glass of water? Via MC, that is correct. That is by the middle cerebral peduncle. And then the cerebrum's little brother tells back to the cerebrum that, okay, the impulses that you have sent is too extreme. I have already received information from the hand. And how did the cerebellum receive information from the hand? From the hand via the inferior cellular peduncle. Okay, inferior peduncle. Okay, after it receives the information, it has modified, the cerebellum modifies the information to the cerebrum. And how does the cerebellum send the modified information back to the cerebrum? By the superior cerebellar peduncle. Okay, this is the only basic thing that I wanted you guys to understand. Okay, this is the only basic thing that I wanted you guys to understand. Okay, so that's it. Now, the cerebellum, okay, so now the cerebellum has Purkinje cells. Okay, so these cells that are Purkinje cells, they're inhibitory cells, are always inhibitory. And what are they inhibiting? They're basically inhibiting the impulses that are sent out from the cerebrum, right? Because if you remember, I told you that the impulses initially sent out from the cerebrum are too extreme. So the cerebellum has to decrease some of the impulses to perfect the movement. So the Purkinje cells are the ones in the cerebellum that are involved with inhibiting the impulses from the cerebrum. Okay, okay, and you have a couple of nucleus. Okay, you have a couple of nucleus in the cerebellum, and those nucleuses are your dentate, emboliform, globose, and fastigial nucleus. So dentate, emboliform, globose, and fastigious, and these are your deep nucleus. And this is a question of emboss. Okay, this is an emboss question, that which of this is a cerebellar nucleus? And your answer is don't eat greasy foods. Don't eat greasy foods for dentate, emboliform, globose, and fastigial. So don't eat greasy foods for dentate, emboliform, globose, and fastigial. That's what it is. Okay, that's that. Okay, so we have studied the nucleus, we have studied the cells, we have studied the physiology of the cerebellum. Okay, now we would like to talk about the structure of cerebellum. Okay, so very basically, the cerebellar structure has, the cerebrum has the vermis, which is present in the middle. Okay, and then it has two hemispheres. Okay, so I'm just drawing this weird looking cerebellum butterfly. Okay, this is a very basic 2D diagram of just to make you understand what the issue is. Okay, so you have this weird looking cerebellum. Okay, this is the medial one, which I wanted to focus, and these are the two lateral hemispheres. The lateral cerebellar hemispheres are associated with movements of the extremities. Okay, so if you want to move your hands and your legs, then the information goes to the lateral hemisphere. If you want to move your trunk, okay, or your central movements, okay, if you want to move your chest, trunk, your abdomen, that information goes to your vermis, or your medial part, so this part. Okay, once again, if you want to move your arms, the information goes to the lateral one. If you want to move your central structures, that information goes to the vermis. As a result, if you have problems with the lateral hemispheres, then the patients will have movement disorders of the extremities. And if the patient has a problem with the vermis, then there will be movement disorders of the trunk. So there will be truncal ataxia, nystagmus, okay, head tilting, and these are all your signs, symptoms of medial lesions, medial lesions. That's it. Okay, so have you guys understood cerebellum? Okay. Okay, all right, perfect. Okay, so only after you have understood, then we will move on. Right now, if you have a problem with the right cerebellar hemispheres, which part of the brain will not receive information? Modified information? Left. That is correct. So left hemisphere. And which part of the body will not receive informations? If there's a problem with the right, that is correct. Ipsilateral body, contralateral brain. Ipsilateral body, contralateral brain. Okay, that's what I said here. So okay. Okay. Are you guys practicing the mnemonic macule patch papule plaque? Macule patch papule plaque, macule patch papule plaque. Okay. Okay. So okay. Okay, so I know it's just a bit out of context. Okay, yeah, okay, so it's just a bit out of context with what we are studying today. But please do not forget macule patch papule plaque because these are very easy to confuse. Okay, and then now you have contralateral brain and ipsilateral arm. Contralateral brain, ipsilateral arm. Okay, so once again, keep on saying that too from time to time for the cerebral hemispheres. Okay, I know it's silly, but it works. So keep on saying that, and hopefully during the exam, you will be extremely confident. Okay, now we have come to a very, very difficult topic. Okay, we have come to quite a bit of a difficult topic, and that is your understanding of basal ganglia. Okay, so it's not that I do not want to scare you. Okay, so although it's difficult, okay, this can be broken down very easily. That's the whole issue. That's why we're all here. Okay, so we will break down basal ganglia very, very easily. Okay, so are you guys ready to start basal ganglia? Can I get 1 minute, please? Okay, all right. So let's start with basal ganglia. Okay, so what is the basal ganglia? So the basal ganglia is performing the same task more or less like the cerebellum is. Okay, so basal ganglia is basically performing the same task that the cerebellum is. So basically what the basal ganglia also does is the basal ganglia also tries to modify the information that is, I mean, it modifies the information that is provided from the motor cortex. So as you can see over here, that this part of the basal ganglia is the one which is modifying the information, and this is the modified information that goes from the brain to the muscles. Okay, and this green line, all the way green straight line, is the information that has been modified by the basal ganglia. So now we are before we start talking about the lectures and this diagram. Okay, this diagram is very important. What we would do is we would focus on mastering this pathway. Okay, in order for us to do that, I will take a small page. Okay, do not worry at all. This pathway will be easy for you after you have completed the lecture today. Okay, just give me 1 second, please. I don't know why this is malfunctioning today. Okay. Okay, so basal ganglia, that's what we will be talking about. And once again, the basal ganglia, okay? The basal ganglia is, this is important for your movements. Okay, the basal ganglia is important for perfecting your movements. Okay, and the basal ganglia basically it contains two things. Okay, it basically contains two things. The basal ganglia consists of S for striatum, okay, and L for lentiform. Okay, L for lentiform. So striatum and lentiform. So striatum is basically your putamen. Okay, there's a structure called putamen and caudate. So caudate and putamen together form striatum, and putamen and globus pallidus. Okay, there is also another structure called putamen and globus pallidus. Globus pallidus. Okay, so we have globus pallidus interna, globus pallidus externa, and both of them together and along with putamen forms lentiform. And this information will be solidified after the end of today's lecture. Okay, so before we do that, let's jump into our pathways. Okay, so basically for basal ganglia, you have two major pathways. Okay, so if let's say this is your, okay, let me see. Okay, so let's say this is a very rough diagram of your, okay, 1 second, please. I apologize. Okay, let's say that these are the two cerebral hemispheres, very roughly drawn. Okay, so these are the two cerebral hemispheres, they're very roughly drawn. Okay, so you have two pathways over here. One is the direct pathway, another one is the indirect pathway. Okay, another one is the indirect pathway. So what's happening is you have this structure over here. Okay, so you have, first of all, what you need to draw or what you need to understand is you have the thalamus. Okay, so that the thalamus is important because the thalamus will relay the information, right? Then beneath the thalamus, there is a subthalamic nucleus. Okay, so this is your thalamus. This is your subthalamic nucleus. Okay, and then you have your basal ganglia structures. Okay, basal ganglia structures. And the basal ganglia structures are basically divided into striatum and globus pallidus. So striatum and globus pallidus. So striatum is once again putamen and corded together. Okay, so this is your striatum, and striatum is, what is striatum? Striatum is basically a part of basal ganglia. Okay, that's all it is. It's a structure. Okay, the striatum is the name of a structure, and this is globus pallidus. And we talked about how globus pallidus have two parts. So this part is globus pallidus externa, and this part is globus pallidus interna. Okay, this part is globus pallidus externa. This part is globus pallidus interna. This is your subthalamic nucleus, and this is your thalamus. Okay, and this is, let's say that this is the spinal cord. Okay. So, okay, so now what's happening over here is that the cerebrum, that your higher center, do you remember how we were talking about the fact that the cerebrum was previously talking to cerebellum? Okay. What the cerebrum also does is it also cross-checks with the basal ganglia that if the movement is perfect or not. Okay. So what's happening is, at first, we will talk about the direct pathway, and then we will talk about the indirect pathway. Okay, so the direct pathway is basically what's happening is you have this information. Once again, let's use this one. So you have this information. So the brain is sending the information directly to the striatum. Okay, and the brain is sending this information directly through the striatum, and this information which the brain is sending out. Okay, this is basically a positive information. Positive meaning that it's an let's say excitatory in information. For, let's say, for example, the brain is excited that the brain wants to do a certain movement, so the brain sends a very excited positive information to the striatum. That is your first step. Okay, so far nothing has been done. Do not get confused or overwhelmed. All we did was draw the diagrams. This is the cerebrum, thalamus, subthalamic nucleus. Okay, this is our spinal cord, and this is our basal ganglia. And basal ganglia has striatum and globus pallidus interna, externa. Okay, so what's happening is, once again, we're talking about the direct pathway. We are talking about the direct pathway. And the brain, what this is doing is the brain is sending a very excited impulse to the striatum. And this excited impulse that the brain is sending is by the help of a neurotransmitter called glutamate. If I'm not wrong. One second, please. One second. I don't want to give you the wrong information because this was right. So it is glutamate. I'm not wrong. Okay, perfect. I just wanted to perfect it. Okay, so it is glutamate. Okay. Okay. So what this is doing is the brain, at first, it sends a positive impulse to the striatum with the help of a neurotransmitter called glutamate. So after it sends that impulse to the striatum via the glutamate, the striatum, what this does is the striatum sends this impulse to globus pallidus externa. So it's basically a very straightforward impulse. But the problem is the striatum, what this does is, once again, the striatum realizes that the brain has sent out an impulse, okay, that the brain has sent out an impulse that is too extreme. Okay, that is too extreme. So the striatum, what this does is this tries to decrease the impulse. This decreases the impulse. And how does it decrease the impulse? This decreases the impulse by the help of an inhibitory neurotransmitter, and that is by the help of a neurotransmitter GABA. Okay, GABA. Good. So GABA, gamma amino butyric acid. So GABA, that's what it does. After it sends the inhibited um, signal to globus pallidus externa. Now this information is inhibited. Now a very inhibited impulse is going from the globus pallidus externa to the globus pallidus interna. Okay, to the globus pallidus interna. Okay, and what's happening is after it goes back to the globe, after it goes to the globus pallidus interna, this inhibited signal is further tried to be inhibited. Like if you try to inhibit an inhibitory signal, okay, if you try to inhibit, and if the thing is, if the globus pallidus internus tries to inhibit the globus pallidus external inhibition, this inhibition of the inhibitory signal results in a primitive excitation. Okay, so if this makes sense, that negative times negative is positive, that's exactly what's happening over here. And that is why basal ganglial mechanism is a bit difficult to understand, because this is the part where it gets a bit confusing. First of all, you had a positive one which got inhibited, and then this inhibition of the inhibited signal resulted altogether in an impulse. Okay, this impulse will go to the thalamus. Okay, this impulse will go to the thalamus, and from the thalamus, what they will do is they will realize that this impulse has been uh, inhibited. So as a result, what happens with the basal ganglia is that the basal ganglia, when it realizes that the globus pallidus interna is inhibiting the globus pallidus externa, this modified impulse is actually not a negative impulse. This is actually a positive impulse. Does that make sense? Let me see if you guys have understood what I just said. Did that make sense? Is anyone confused? Is anyone confused? Okay, I will repeat. Okay, this is worth repeating. Okay, because this is a bit difficult to understand. Okay. So first of all, what's going on over here? Okay, let's cancel everything. Okay, let's cancel everything. Okay, so what's going on over here? So everything that happened till now, it was at first you had glutamate, which was coming from the brain to the striatum. From the striatum, this information got inhibited, and then it went to globus pallidus externa. Okay, this got inhibited by the help of GABA. Okay, after this got inhibited, this signal was sent forward to globus pallidus interna. And globus pallidus interna, what they did was they tried to inhibit the inhibitory signal, and this resulted in a reflex signal that was actually excitatory, not inhibitory. Does that make sense? Now, did you understand? Okay. If you can understand this confusion, then everything is clear. And everything is clear. Okay. If anything, try to remember that negative times negative is positive. Negative times negative. If you try to inhibit an inhibitory neurotransmitter, this results in a positive. This results in a positive signal. Okay, this results in a positive signal. So that's all I wanted to make you guys understand. So now this positive signal, okay, this positive signal is further forwarded from the thalamus back to the cortex by the help of glutamate. So overall, did you have increased impulse of the direct pathway or decreased impulse of the direct pathway? Increased impulse. That's exactly what I wanted to make you guys understand. So that is, you guys had increased impulses. So once again, let's discuss the direct pathway one more time. Impulse from the brain going to the striatum with the help of glutamate, which is a positive neurotransmitter. Then the negative neurotransmitter inhibited the glutamate, okay, and then it decreased. Then it tried to decrease the negative more, so it became positive. And then this positive was transferred back to the brain with the help of glutamate. Okay, so all together in the direct pathway, the overall impulse has increased. So the patients in direct pathway, will they have increased motion or decreased motion? Increased motion or decreased motion? Increased motion. Increased motion. Okay. Okay. Did every one of our doctors understand this pathway? Okay, everyone. Before I move forward, Doctor, we have Dr. Lynn, Dr. Jordan, Dr. Hussein, Dr. Grassi, Dr. Tamilola, everyone starting from them to the end to Dr. Maheshwari, everyone. Okay. If anyone has a confusion, this is their absolute time to tell me now so that I can repeat it. Once we go forward, we will have difficulty in talking about this again. What questions can they ask? The thing is, they can ask you questions about the pathway. Okay, the questions come in various amounts of form. That's what it is. But you do not have to worry about the questions coming from the questions if you have mastered this diagram. Okay, why increased movement? Okay, why increased movement? And so if you are asking why is there increased movement in direct pathway, once again, why is the movement increasing? First of all, you have a positive impulse from the brain, goes striatum. The positive impulse got inhibited to the globus pallidus externa. The globus pallidus externa sent out more impulses to the globus pallidus interna, and this was inhibited. So you inhibit the inhibition. So negative times negative results all together in a positive impulse. And this positive impulse is further. So positive times positive is still positive. So this resulted in an overall positive impulse back to the brain. Okay. Did you understand? Inhibition of the inhibitory signal. So what happens when you inhibit the inhibition? Okay, so how can I give you a better example? How can I give you a better example? Okay, let's say, right, it cancels out. Okay, so let's talk about this in a general bodily, in a general life-like situation. Life-like situation. Okay, so inhibition is basically, let's say there is something that you want to do. Okay, and that thing is not inhibited or permissible by law. Okay, so let's say you want to, let's say you really want to drink alcohol on the streets. Okay, and in the United States, drinking alcohol on the street is a crime. Okay, so this is just an example. So let's say you want to drink alcohol on the street. Okay, but your body or your brain has inhibited that action. Okay, so you will not do that. Okay, so right now, what if you inhibit that inhibition, meaning that you cancel out that inhibition, that, okay, I do not want to stop myself from drinking alcohol on the street. So as a result, what happens? What happens is if you have loss of inhibition, okay, if you have loss of inhibition, you start performing the action. So that's exactly what's happening over here. So there's loss of inhibition. As a result, they're performing more. That's what it is. Okay, is that understood? Is that understood? Is globus pallidus externa involved in direct pathway? Yes, it's involved in direct pathway. That's what we just talked about. Globus pallidus externa. Okay. Okay. Are you guys confident? Should we move forward with the indirect pathway? Okay. Okay. So we will move forward to the indirect pathway. Okay, we will move forward to the indirect pathway. Let's draw another diagram for the indirect pathway. I do not want to use the same diagram. Okay. One second, please. Okay. Okay, one second. And okay, so right now we'll be talking about the indirect pathway. Okay, we talked about the direct pathway already. So let's draw the brain again. Then we drew the thalamus. Okay, T for thalamus. Okay, let's see if you have any questions. Okay, so no more questions. Next, what we would draw is the subthalamus. We'll draw is the subthalamus. Okay, and then we will be drawing the basal ganglia. Okay, okay, millions. So this is the striatum. This is the globus pallidus. Okay, so This is striatum. This is globus pallidus externa, globus pallidus interna. Okay, so what's happening with the indirect pathway is right now, first of all, for the indirect pathway, the brain again sends an impulse to the striatum. And once again, this impulse is a positive impulse, okay, and it is carried by glutamate. So what happens with striatum? Now, the striatum, what this does is, right now, striatum sends the impulse back to the globus pallidus externa, okay? And we know that the striatum has decreased the impulse. So right now, the overall impulse that is going from the globus pallidus externa to the globus pallidus interna, is it increased or decreased? Is it increased or decreased? Decreased, correct? Okay, so the overall, this is a decreased impulse that is going to globus pallidus externa. So once the globus pallidus, I'm sorry, through the globus pallidus interna. So once the globus pallidus interna, I'm sorry, it does not send the impulse to globus pallidus interna. It says the globus pallidus externa for indirect pathways sends the impulse all the way to the subthalamic nucleus. Okay, the globus pallidus externa sends the impulse all the way to the subthalamic nucleus. Okay, subthalamic nucleus. And what the globus pallidus externa does is this impulse that the globus pallidus externa, that what it does is it sends the negative impulse. Okay, it sends a negative impulse. And can you guys just give me 1 second? Let me just figure out. Even I got confused myself. I have 1 second, please. I do not want to teach you guys the wrong things. Mhm. Okay, perfect. Okay. Okay, so this is extremely difficult, and at times I get confused. Okay, so I don't want to teach you guys the wrong thing, so I'm just took some time to figure it out again. Okay, okay. So my apologies. So let's go back to the diagram. Okay, so we're talking about the indirect pathway. So first, again, number one, what's happening is you have the cerebrum, which is sending out the impulses to the striatum, and the striatum is now sending a negative impulse, okay, to the globus pallidus externa. So altogether, this impulse that is sent out is a negative impulse that is going back to the subthalamic nucleus. Now the subthalamic nucleus, what this does is the subthalamic nucleus, what this does is they try to send a positive impulse to globus pallidus interna. Now it's okay. So it sends an impulse to globus. So now, even if you try to send a positive impulse to the globus pallidus interna, okay, okay, so how so if you try to increase the negativity, so that's all that's happening. Okay, this is why I got a bit confused. If you try to increase the negativity, is the overall impulse that is going from here to here, is this increased or decreased? Increased or decreased? Decreased. That's okay, that's all I wanted you guys to understand. That's it. So it got decreased. So the overall impulse got decreased more. It got decreased more. Okay. So now this decreased impulse, okay, what the globus pallidus interna will do is that the globus pallidus interna, what this will do is they will try to, what this will do is that the globus pallidus interna will try to, okay, with this globus pallidus interna, what they will try to do is, let me use the yellow one, okay, and that's it. Okay. Okay. That's what's happening. So what's happening is you have the negative impulse that is coming from the subthalamic nucleus to the globus pallidus internus, and then the globus pallidus internus, what they would do is they would try to I think there's an issue because it's not making sense to me right now. Okay, that's what it is. Okay, this is okay. Okay, this is what's happening. So what's happening is that the globus pallidus interna again will try to increase the negativity. Okay, what they will do is they will try to increase the negativity again. So what happens is overall the negativity stays so increased. Okay, the negativity. So what happened was, let's come from the beginning again so that we don't get confused. Number one, the brain is sending the impulses to the striatum. This got decreased. Okay, and this decreased impulse travel from the striatum all the way to the globus pallidus externa. Globus pallidus and externa further tried to decrease the impulse, right? And this decreased impulses went back to the striatum. Striatum tried to increase the negativity. Okay, so more negative impulses are going back to the globus pallidus interna. Then the globus pallidus interna sends this signal all the way back to the thalamus. Okay, and then this thalamic impulse is still negative. Okay, so there is still a negative impulse. So there is still a negative impulse that is going back to the thalamus. And now the thalamus, what the thalamus does is that the thalamus tries to increase this negativity again. So this is the issue that for which there has been so many confusions. It's because the globus pallidus interna in turn decreases the impulse more, and this decreased impulse is increased, meaning the thalamus increases the negativity. Does that make sense? So altogether, the impulse that is going back to the brain is a negative impulse. Did that make sense? Because I will try to repeat the whole thing again. You are lost. Okay, so am I. Okay, so am I, because this is a bit confusing, but do not worry. We will try. Okay, we will try to break it down again. Okay. 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 Let's do this again. Let's do this again. Okay. Let's go back. Let's go back. Okay. This gets a bit confusing over here, and then fully everything will make sense. Okay. Okay. So what's happening? Okay. What's happening over here is, okay. So first of all, you have this impulse that is coming from the brain to the striatum. Okay, this impulse is a positive impulse, right? It's sent by glutamine. Now what's happening is this positive impulse is sent from the striatum to the globus pallidus, and this is by the help of GABA. Okay, this is by the help of GABA, globus pallidus externus. Now, is this impulse increased or decreased? Let's take a step. Is it okay? Okay, decreased. Okay, and now this decreased impulse is further decreased. So you decrease the further decreased impulse, and this goes to the subthalamic nucleus. Okay, so this decreased impulse is further decreased. So what happens when you decrease what happens when you decrease the decreased? Like, what happens when you do negative times negative? The answer is positive, right? If you try to decrease the decreased, the overall impulse, is increased or decreased? Increased. That is correct. So overall impulse right now is increased. Okay, so this increase. So the impulse right now that is going to subthalamic nucleus, it's an increased nucleus. Okay, it's an increased one. Okay, so what happens is that the subthalamus, what this does is the subthalamus sends this overall increased impulse back to the globus pallidus interna. If that does, now this overall impulse, is it increased or decreased? If it increases, increase. Overall, is it increased or decreased? The subthalamus to globus pallidus interna. Increased, that is correct. So the overall, this is it. Now again, what happens is the globus pallidus interna, this tries to decrease the impulse. Okay, this tries to decrease the impulse, and after this decreased impulse goes to the thalamus, now this last impulse, is this increased or decreased? If you try to decrease, perfect. So now overall, there is a decreased impulse going back. Now what happens is the thalamus tries to send the impulse back to the brain, but what this does is it tries to increase the negativity. So the overall impulse, is this increased or decreased? So the overall impulse from the thalamus to the brain, is this increased or decreased? Decreased. Good, thank God we completed this. Okay, that's exactly what's happening, and we have succeeded.
Excuse me, doctor.
Okay. Hi. So
Hello.
who are we? Yes. Okay.
The,
Okay. What is your question, please?
can I participate here, please? Because I read from some resources different
Okay. What do you want to inform us? What is the information?
May I share my what I learned here, and if I If I got wrong, you can correct me.
Okay, perfect. Let's see what you have learned and let's see if there are extra things that we should know or not. Okay, go ahead.
Okay, in the first pathway, the direct pathway, I learned that the globus pallidus internus is the only one share in this pathway.
The globus pallidus internus
Yes.
is the only one that is shared
Yes,
in.
and the signal or the direct pathway start from the substantia nigra and then go send inhibitory or GABA to the GBI.
Okay.
And the GBI sent inhibitory to the thalamus.
Okay.
The first one is inhibition, and from GBI to the thalamus is also inhibition.
Okay.
And inhibition of the inhibitory will result in stimulation, excitatory impulses. So here we have excitatory impulses from the thalamus to the cortex.
Okay.
And this is increased movement or motion.
Okay.
This is the first one. In the second pathway, the indirect pathway, here the globus pallidus internus is the first from the substantia nigra to the globus pallidus externus. And then this sent inhibitory impulses or GABA to the subthalamic nucleus.
Okay, that's what's happening over here then.
Yes, inhibition of the inhibitory result in excitatory impulses from the subthalamic nucleus.
Okay, this
stimulates the GBI to send inhibitory impulses to the thalamus.
Okay, that's what's happening then.
Okay. This will inhibit the thalamus here.
Okay, so this is resulting in a total inhibition of the thalamus.
Yes, and here there is no excitatory impulse, will exit the thalamus and no motion.
Okay, so what is the difference between our text and your text? The main difference?
At first, in the direct pathway, you said the impulses go to the globus pallidus internus, then to the externus, then to the internus.
Okay, so that is different from our knowledge to your textbook knowledge. Okay.
And the second one, in the indirect pathway, when you said the thalamus will send excitatory impulse, I think in the indirect, there is no impulses will be sent from the thalamus. So no motion, and this is will result in inhibitory of unwanted movement.
Okay. Okay, perfect. So the second thing which you are telling me right now, the one which is for the indirect pathway, okay, this is exactly the same that we have just studied. Okay, and the thing is, the last one which I was just discussing with you, that was confusing because that did not make sense to me because that was not completing. This has been completed. So stay online. Okay, let me just tell you the pathway again and see if it matches with your indirect pathway, and then we will talk about the matching with your direct pathway. Okay.
Okay, thank you.
What we are saying with our indirect pathway is, first of all, you have information from the brain to the striatum, which is a positive impulse. Then this positive impulse from the striatum goes to the external, which is inhibited, and inhibition of positive results in a total amount of inhibition. Okay. And then external impulse from the globus pallidus external goes to the subthalamic nucleus. So you inhibit the inhibitory results all together in a positive. And then this positive impulse from the subthalamic nucleus goes to the globus pallidus internus. So you increase the positivity, and then the overall impulse is positive. Then from globus pallidus interna, it goes to the thalamus, and you try to decrease the negativity. So the overall impulse right now is negative. So you decrease the positivity, so it's negative. And then you try to increase the negativity. So overall impulse is still negative. So does this match with your text? Dr. Yusuf, I suppose. Does this match with your text? Which we just said, indirect pathway?
You mean that there is the net result of inhibition of the thalamus, yeah?
Yes, in indirect pathway, net result is inhibition. Does this match?
Okay. So my question is if there is still excitatory impulse from the thalamus with this inhibition?
Okay.
Or no?
What is your question once again? What was your question?
After inhibition of the thalamus in the indirect pathway.
Okay.
Is it still there is excitatory impulses exit from the thalamus toward the cortex?
No, okay, so what's happening is the thalamus tries to increase the negativity. So overall, the negative, the overall, the impulse is negative. Now, does it make sense? Is it clear now? So if the thalamus tries to increase the negativity, the overall impulse is still negative. So the motion is decreased. Now, did you
Okay.
understand? Okay. Let's say
Yes.
the thalamus is trying
Yes.
to increase the negative. The thalamus is trying to increase the impulse. The only impulse that the thalamus can increase is the negative impulse because the globus pallidus interna is sending negative impulse to the thalamus. The overall impulse is negative because the thalamus is trying to increase the negativity. Now, does it make sense?
Yes.
Is it clear
Yes.
now?
Mhm.
Okay.
Yes. Thank you so much.
Okay, you are welcome. And once again, which textbook are you using?
Um, uh, uh, I learned
No.
from Dr. White from Kaplan.
Oh, you learned from okay, so that's another note. Okay. So what's happening is, so thank you so much for once again, I appreciate your sharing of your resource and your knowledge with us.
You're welcome.
Okay,
Mhm.
thank you so much
Thank
for
you.
doing that. Okay, this clears up a lot of confusion. So what's happening is overall, all of this, all of this can be broken down into very simple direct pathway, indirect pathway. Okay, overall impulse in direct pathway increased. Overall impulse in direct pathway decreased. Okay, the main confusion is when you try to break down the whole thing. Okay, and you will receive some questions. I won't lie to you, you will receive some questions on how this is happening. But if you cannot remember, because I know this can be a bit overwhelming for a lot of students, because this is an extremely difficult thing to master. Okay, this is an extremely difficult thing to master, and as you have just witnessed, even I got a little bit confused while I was trying to explain to you guys that what's going on. So that's that. So even if you guys forget to remember the mechanism, if you guys can remember this, that's enough. Okay, just give me 1 minute, please. Okay, so okay, so the indirect line from thalamus. Okay, so do you guys want to do another recap the pathways? Do you guys want to do another recapitulation of the pathways? I got dizziness. Okay. Okay, what's your question, Dr. Hussam? Yes, what's your question, please? What is your question? What is your question? Which of these nuclei can decrease? Which of these nuclei, if stimulated, can decrease Parkinsonism manifestations? Okay, so Parkinsonism manifestations can be decreased by stimulations of the dopaminergic nuclei, right? So your answer is the dopamine. So did they specify you by asking D1 or D2? Dopamine D1 or D2? Is that what the question was? What was the question, Dr. Hussam? Okay, you know what? Let's do a revision of the pathways again because it's confusing everyone. Okay, we will do another review. Okay, do not worry. Okay, do not worry. I will solidify this information once and for all. Okay, no problem. Okay, every one of you will understand. Okay, first of all, the pathway that we are discussing right now is the direct pathway. Okay, the pathway that we are discussing right now is the direct pathway. Okay, we have drawn the brain, we have drawn the basal ganglia, we have drawn the thalamus, we have drawn the subthalamus. Okay, right now the brain. Okay, so once again, okay, so striatum, globus pallidus externa, globus pallidus interna, thalamus, subthalamus, and cerebral hemisphere. Now you guys will answer for me. Okay, you guys will tell me. So first of all, blue is stimulatory, yellow is inhibitory. Okay, blue is stimulatory. Blue is glutamate, and your yellow is GABA. Okay, now let's start from the brain. Okay, so let's talk about the direct pathway. The direct pathway. First of all, what's happening with the direct pathway? What is the signal that the brain will send to the striatum? Answer. Can I get some answers, please? Stimulatory or inhibitory? Blue. Right. Okay. And striatum will also receive, as per Dr. Yusuf just mentioned, that the striatum will also receive information from the substantia nigra. Okay, but we will not mention substantia nigra right now because we want to keep this simple. Okay, we want to simply understand what's going on. Okay, so we will just mention this from the brain. Okay, so now right now this is a positive impulse. What will happen? The striatum will send the impulse to the globus pallidus. What will they do? Will they use the positive or negative? Will they use the positive or the negative? Negative. Okay. So they're sending the impulse to the globus pallidus. Okay, that is negative. Now this information from the globus pallidus will go to the globus pallidus interna, and if they try to inhibit the inhibitory signal, okay, if they try to inhibit the inhibitory signal, will they try to, will this result in an overall increase or decrease? Overall increase or decrease? Overall increase. Will go from here to here, okay, and the overall signal will increase, or the overall signal that is going to thalamus will increase, okay. And then from the thalamus, right now the thalamus, what will they do? Will they try to increase or decrease the impulse? They will try to impulse, and overall this impulse right now is a positive impulse because they have just enhanced the positivity. How did this happen? First of all, positive got inhibited, so negative. Negative got inhibited, so inhibition of negative is positive, and then the positive got positive again. So the overall motion is increased in direct pathway. Have you guys understood this? Have you guys understood this? Okay. Okay. Next one. Next one is, now we will talk about the indirect pathway. Okay. Now we will talk about the indirect pathway. Now, if we start about the indirect pathway, first of all, again, in information from the brain to the striatum, increased or decreased? Increased or decreased? Increased. From striatum to the globus pallidus externa. Is this overall impulse right now increased or decreased? Decreased. Okay. Now from globus pallidus externa all the way to the subthalamic nucleus. So, and now this overall stimulus. If you try to inhibit the inhibition, what is the problem with this impulse? Is it increased or decreased? Okay, it's increased. Okay, right now it's increased. And now the subthalamic nucleus will try to send this impulse back to the globus pallidus interna. Now this impulse over here, is it increased or decreased? Increased. That is, the globus pallidus interna will send an inhibition to the thalamus. Okay, is this impulse right now increased or decreased? You have decreased the increase. So what decreased? Okay, you have decreased. Okay, so there is overall decrease. Right now, the thalamus will try to send this impulse back to the brain, but it tries to increase the negative. Okay, the thalamus will try to increase the negative. So overall, this impulse right now that has reached the thalamus, that has reached the brain, is it increased or decreased? Decreased. Okay, this has decreased. Okay, so this is your indirect pathway. Now, is it clear? If it's not clear, I will do it once again, no problem. Clear? Okay. Dr. Mazar Yusuf, is it clear? Do you have any more questions? Dr. Yusuf? Okay. Okay, thank you so much. Once again, thank you so much, Dr. Yusuf, for sharing your information from your textbook and knowledge from Kaplan. Okay. So, and once again, overall, if you try to remember, direct, increase movement, indirect, decrease movement. That's all. Okay. Okay, so should we move forward? Okay, so let's move forward. Okay, let's go back to our text right now. Okay, let's see what our text says. Okay, so basically we have studied about the basal ganglia. Okay, so that's what the basal ganglia is. Right now, the basal ganglia is basically what is the basal ganglia. So this is basically your, as we talked about, it consists of striatum. The striatum, which this is basically your collection of pudent and caudate of putamen and caudate nucleus. Okay, putamen and caudate nucleus, and lentiform is basically your putamen plus globus pallidus. So putamen plus globus pallidus is your lentiform nucleus. Then we talked about the pathways. I will not go into details of the pathways anymore because I have just talked about them. Okay, and then there's another thing which we have to know is that the direct pathway is associated with D1 and the indirect pathway is associated with D2. And also keep in mind that we have said that the impulses will come from the brain, but they will also come from the substantia nigra. That's also what it is. Okay, so both brain and substantia nigra together. Okay, so that's all. D1 for direct, D2 for indirect. Okay, did you understand? Okay. Okay. I cannot believe I got confused while I was trying to explain you guys about the indirect pathways, showing how difficult this whole thing is. So once again, my apologies for getting confused. Okay, but to be honest, I mean, like, this is a thing to get confused about if I have to, because I do not want to teach you guys the wrong things, right? So once again, my apologies, and I am as honest as possible, and I have taught you from my own knowledge, so I'm bound to get a little bit confused. I hope you guys can excuse that. Okay, I apologize. And if you guys are ready, then we can move forward. Okay, look forward. Okay, so this diagram over here, I want to keep this diagram for later. Okay, I want to keep this diagram for later. I'm going to tell you why I want to keep this for later. That's because when we discuss about MRI and CT scans, the MRI and CT scans, then I want to use this diagram to explain the MRIs and CT scans. There's no use of learning this diagram right now. So if that is good with everyone, then I would like to move forward. Is that okay? Okay. So do you want to take 5 minutes before we move on to the next page? Because we have just learned something really difficult, and clear our heads for 5 minutes. Yes, that's correct. So this and that for later. Okay, so Dr. Hossam, this is, I want to give you a responsibility. Okay, Dr. Hossam, I want to give you a responsibility. Your responsibility is making me recall and remember if by any chance I forget to discuss that table of the neurotransmitters. Okay, that okay, Dr. Hossam? Okay, thank you so much. So that's what it is. Okay, so that's what we're going to do. And so before we move on to the next diagram, so let's take a small break before we can do that and clear our heads. Okay. Okay. Okay, can you guys hear my voice? Is everyone back from the break? Is everyone back from their break? Okay, everyone who is present and is back from their break. Okay, perfect. Okay, good. So hopefully we have everyone. So it's 12:45 as of right now, and let's start with the next page. Okay, so so far is neurology getting better to understand? Do you think our lectures are helping you guys, or is it making it more difficult or confusing? Because is the pace of the lecture okay? Basal ganglia confused me. Okay, so we can redo basal ganglia. It was good until basal ganglia. But have you guys understood the explanation of basal ganglia? That's my question. It is a bit difficult, but have you guys understood it? Okay. So if you guys have understood it, then you guys should be really proud of yourself for understanding such a difficult topic. A lot of your friends will not understand this. Okay. So you will have colleagues who are in really high positions in their jobs, and they will have very little knowledge about basal ganglia. Okay. So what you can do is you can help them out. Okay. What you can do is you can take 5 seconds of your day, try to sit and explain this to someone else. If you try to do that, what you can do is this will also get perfected in your head, and then the knowledge will pass on. Okay, so I think that's a good way by which you can make everyone else understand basal ganglia. If you try to teach your friends about basal ganglia, try to teach them about the pathways, draw the whole thing out and do it step by step, then you will realize that you have also perfected the basal ganglia. Okay, that is one way in which you can do this. Okay. Okay, so let's start with the second one. Okay, now the thing which we are going to discuss is we are going to discuss about the different regions of your cerebral cortex. Okay, we are going to discuss the different regions of your cerebral cortex. Okay, so in order for us to do that, let's draw the cerebral cortex very roughly. Okay, and okay, this is basically what we are going to do. Okay, so the very roughly drawn, this is basically your cerebral cortex. And how many regions does the cerebral cortex have? First of all, let's talk about the different lobes. Okay, first of all, let's talk about the different lobes. So how many lobes does the cerebral cortex
Doctor,
have?
please share your screen.
Oh, my bad, I'm sorry. Okay, my apologies. My apologies. Okay, so can you see the screen right now? You guys see the screen? Okay, good. Okay. Okay, so this is the rough diagram of the cerebral cortex that we were talking about. So in the cerebral cortex, how many lobes does the cerebral cortex have? How many lobes does the cerebral cortex have? 4 lobes. That is correct. How many? So what 4 lobes? First of all, we have the frontal lobe. Okay, so first of all, we have the frontal lobe. Okay, okay, and this part of the this part of the cerebrum, this part of this cerebrum, this is your central sulcus. This is your central sulcus. So central sulcus is the division which is dividing the brain into the frontal lobe, okay, in the front. And then you have, what is the name of this lobe? What is the name of this lobe behind the frontal lobe? What is the name of the lobe behind the lobe? That is correct. This lobe here is known as the parietal lobe. Okay, and this is very basic medical knowledge. I'm pretty sure you guys know the names of the lobe. What is the name of this lobe over here? What is the name of this lobe? Temporal. And what is the name of this lobe over here? Occipital. Okay, so this is basically your knowledge of all the lobes. Okay, so basically frontal, parietal, temporal, and the occipital lobes. Now what we are going to do is, okay, now since we know the lobes, let's draw the centers. Okay, so let's draw the centers. So the center that is in front of the central sulcus, okay, the center that is in front of the central sulcus, this center is known as the primary motor cortex. Primary motor cortex, meaning that this is the part of the brain that is involved in making decisions of your muscular movements. Okay, primary motor, and then you also have premotor. Then you also have premotor. So primary motor, and this is premotor. Okay, this is premotor. Okay, uh, please bear with me. I will explain to you how everything is happening. Okay, do not worry. Just identify the centers first. So this is basically your primary motor cortex. Then this is your premotor cortex. That right? And then you have this. Then you have the small area over here. This is known as the frontal eye field. This is known as the frontal eye field. Okay, and this region over here in front of the frontal eye field, this is a very important region because this region is known as prefrontal cortex. This region is known as prefrontal cortex. Okay, so let's talk about these centers for a while. Okay, so first of all, let's say that you decide that you want to make a movement. Let's say you want to decide that you want to remember. Let's go to our example of grabbing the glass of water. Okay, so there's a glass of water over here. Okay, and you decide that you want to go and grab this glass of water. So the first thing is your prefrontal cortex makes the decision. Your prefrontal cortex makes the decision, okay, and then it sends impulses from the prefrontal cortex to the premotor cortex. From the premotor cortex, that impulse is then thought of again, and then it is sent to the primary motor cortex. Then from the primary motor cortex, obviously the impulse goes through the muscles of the hand, and then it makes the movement. Okay, so the next time when you think about making a small movement, even when you are typing or doing anything or everything, okay, think about the movement. First of all, when you think about the movement, you realize that the part of your brain which you are using to think is your frontal cortex, right? And then when you decide to transform that thought into an action, okay, what do? Your brain sends impulses from the prefrontal to the premotor, premotor to the primary motor, and from the primary motor, this gets sent out all the way to your muscles. That's what it is. Okay, is everyone clear about the motor movements? Is everyone clear about the motor movements? Okay. Everyone? Okay, perfect. Next one. Next one is, so if this is the central sulcus, the area in front of the central sulcus is primary motor cortex. The area behind the central sulcus, this is the primary somatosensory cortex. So this is the primary somatosensory cortex. Okay, so this cortex over here is associated with receiving informations about different types of bodily sensations. That is from the face, from the rest of the bodies and arms. And we talked about this, that how the ventral posterolateral is for the rest of the body and the ventral posteromedial is for the face, from the thalamus. And these informations are coming to the primary somatosensory cortex. Okay, and we also have another area over here. This area is known as somatosensory association cortex. Okay, so not only does it go to the primary somatosensory cortex, this also goes to the somatosensory association cortex. Okay, now let's talk about this for a while. Okay, so now we know that there are different types of sensations. Okay, so there could be a good sensation, there could be a bad sensation. Okay. Okay, so if we talked about the limbic system, right? We talked about the limbic system. Okay. Okay. Uh, if you get into a fight with someone, okay, if you get into a fight with someone, and let's say that this is your face, and someone punches your face. Okay, so you get punched in the face. Will that make you happy or will that make you angry? Fast answers, please. How commonly will that make you happy? Will that make you angry? The answer is in everyone, it will make you very angry, right? So what's happening over here is, first of all, you get punched in your face, so that produces a sensation. That sensation, what happens is that sensation goes all the way through your spinal cord up to the thalamus. From the thalamus, it goes to the ventral posteromedial. ventral posterior medial. From the ventral posterior medial, this goes to the primary somatosensory cortex, and then you receive that information. Then your brain, what it does is the brain receives that information, the brain goes and the brain sends that information to the somatosensory association cortex, okay, to process that information. And from the somatosensory association cortex, all of that information goes to the limbic system. Okay, all of that information goes to the limbic system, and our limbic system is the hamid. We talked about this hamid, that is hippocampus, amygdala, mammillary body, anterior thalamic nucleus, entorhinal cortex, and your cingulate gyrus, and that's where it goes. And if it produces a feeling, we talked about the fact how limbic system is associated with the sensation of feeling, okay? And that feeling that you are feeling, that is you're feeling angry, that's it. That is exactly what's happening with your brain over here. So your limbic system is the one which is involved with making you feel angry. So this is the whole process that is going on in your brain, all the way from the stimulus that was your punch to the face, to your brain, to your limbic system, and your feelings. Same way, if you receive a sensation that is that makes you happy. Okay, let's say you receive a sensation that makes you happy, and we know that if our mother tries to kiss us, okay, so if we receive a kiss from our mothers, okay, so if our mothers kiss us, okay, and then what happens, that feeling instantly makes us really happy. The same thing happens. So you receive a kiss from your mother, and that goes all the way from your primary sensory cortex to your somatosensory association cortex, and from there it goes to your limbic system. And then instead of making you feel angry, now what it does is it makes you feel happy. Okay, now what it does is it makes you feel happy. So that's exactly what's happening over here with the limbic system. It's making you feel happy. So that's that. And another one is in, along with making you feel different types of feelings, the limbic system is also associated with forming the memories. So if you get punched in the face, do you remember that, or do you not remember that, or do you forget that instantaneously? Do you remember, do you not remember it? Of course you remember it. Okay, you remember it. And also at the same time, if your mother loves you, do you also remember that love, or do you forget that love right away? Quick answer, please. You remember it. Okay, what if you have a fly that comes and sits on your cheek? You have a fly that comes and sits on your cheek, and that happens on a regular basis. Do you remember it or not remember it? Do you remember that? No, you don't remember it. You do not remember a fly coming and sitting on your cheek, although that sensation was processed. But the problem was, since it did not evoke any feeling, since it did not evoke or start any feeling by the limbic system, your amygdala, which is your part of the limbic system, your amygdala, did not process that information, and you did not remember that feeling. So that is basically what's happening with the brain. Okay. Okay. Did you guys understand about how the brain is working? How everything's been going on? Okay. Everything in your body, from beginning to light to sound, everything. Okay. Same thing. Okay. Now let's talk a little bit about your visual cortex. Okay. Let's talk a little bit about the visual cortex. So this is, as we talked about, this is the visual occipital lobe. Occipital lobe contains the, so let's use a different marker. Okay. 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 So this is your occipital lobe, and now your occipital lobe, it contains your primary visual cortex. This is the visual cortex. So you view something with your, let's say these are your eyes, right? And when you see something, it goes to the optic tract, it goes to the optic nerve, optic chiasma, optic tract, and then all the way it goes to your primary visual cortex. Okay, and then when it reaches your primary visual cortex, same thing happens again. What happens with the primary visual cortex? The visual cortex sends impulses back to the limbic system. Okay, now if you see something which makes you happy, you either remember it. If you see something which makes you angry, you remember that too, but a feeling has to be evoked. If you get a feeling, your limbic system will process it, and it will remember it. Okay, so is that understood? Visual cortex? Yes, no? Once again? Did you guys understand this? Can I get some answers, please? Do you guys understand this? Okay. Next one. Next one is so we have talked about the occipital lobe. So the next one is this lobe over here. Okay, this lobe on the temporal lobe. This lobe is your auditory cortex. This is your auditory cortex. This is your auditory cortex. And the same thing is happening with your auditory cortex. You receive the information, and the information goes from the middle geniculate body of the thalamus to the auditory cortex, and from the auditory cortex all the way again to your limbic system. Either it makes you happy, or it makes you angry, or it makes you sad. If you remember it, it gets formed into a memory, right? And that's exactly what's happening. So did you guys understand all the regions of the brain? Did you guys understand the regions of the brain? Okay, so we have two more regions, then we're done. Okay, two more regions for the brain. So very important region that is over here. This is one region. Okay, does anyone know which regions I'm talking about? And they have another region over here. What are these two regions? Very good. Okay, so we are talking about the Broca's and the Wernicke's area. Wernicke. So Broca's area and Wernicke's area. Broca's and Wernicke's, these are basically your areas which helps you, which are your verbal areas. Verbal meaning these areas, they help you talk. Okay, verbal, they help you talk. And if we have ischemia or stroke to the Broca's area or to the Wernicke's area, then we will get verbal changes, and that's why you hear problems with your that's what it is, aphasia. That's what it is. Okay, so that's that. So have you guys understood all the regions of the brain? Okay. Okay, so let's back. Okay, so hopefully we have covered almost everything from over here. Okay, that's exactly what's happening. Okay, so the last thing that we want to talk about is cerebral perfusion. But the thing is, I wanted to keep cerebral perfusion for tomorrow because this is another high yield difficult thing that you have to understand. So would you guys okay stopping the lecture for first right now? Yes, we can stop over here. This is the perfect time because starting cerebral time. Okay, so let's stop the lecture over here. Okay. Yep, we did a pretty difficult topic. Okay, so let's start with some UWorld notes for today. How about that? Okay, we have not discussed UWorld notes yesterday. So do you guys want to do UWorld notes? Yes or no? Or are you guys exhausted? Who over here is exhausted? Okay, so for so you can stay for zoned out. Okay, so you're zoning out. Even I am zoning out because it's extremely difficult for me to to make you guys understand. Okay, it's one thing trying to understand yourself, and then it's another thing trying to make someone else understand, specifically 30 people. Okay, so what that's, and for I apologize for that, for phasing out. I was also phasing out by myself. Okay, so that's that. Okay, so let's start with the UWorld notes. Okay, you guys can take a 2-minute break while I prepare everything. Okay, no problem. So I'm just going to prepare the UWorld notes really quick. Okay. Okay, so do we have a student who has joined the Facebook group? Do we have any student who has not joined the Facebook group as of yet? Okay. Okay, let me just send you the link. I have sent you the recording for yesterday. It's in the so I have sent out the email last night by myself because only one of us is working right now. The other one is not working. So I have sent out the email by myself last night, and I have placed the recording for last night. I have placed the recording for last night in the email which I provided, which contained the recording. So that's that. Okay. And if you check the email from last night, you can see that the recording is there. Okay, the recording is there. Okay. Okay, so this is the Facebook group link. Oh, I think I'm doing okay. Okay, so this is the Facebook group link where you can provide, where you can access the group. Okay, please send your invitation so that we can accept you as soon as possible. For anyone who has not joined the Facebook group, please join this group right away. Okay. Okay, give me 1 second. Okay, so can you guys see my screen? So can you guys see my screen? Let me see. Okay, good. Okay. So please feel free to unmute yourselves and participate in the URL so that I don't have to go back and see who has written what. That helped me save some time. Thank you so much. Okay. Okay. Okay, 1 second. Okay. Have you guys heard of okay. So have you guys heard of ichthyosis vulgaris? Ichthyosis vulgaris. That's a dermatological condition. Okay, let me show you a picture of ichthyosis vulgaris. Okay, so this condition over here where you see that the frog like that toad skin. Okay, this toad skin appearance. This is known as ichthyosis vulgaris or tick skin. Okay, does anyone know what the problem with this patients are? Does anyone know what the problem with this patients are?
Something filagreen gene.
Perfect. So there is a mutation in filagreen gene. Filagreen gene. And what happens is you have epidermal hyperplasia and keratin desquamation. Okay, that's that. Okay. Okay. What do you see in a patient with history of vesicular skin lesion? Vesicular skin lesions and signs of malabsorption. What do you see in a patient who has a history of vesicular skin lesion and signs of malabsorption? What is this disease called? It's easy.
Celiac.
Celiac disease.
Okay. And what is the name for the dermatological condition of celiac disease?
Dermatitis herpetiformis.
Dermatitis herpetiformis.
That is correct. So dermatitis herpetiformis. Okay. Once again. Okay. So this is dermatitis herpetiformis. Okay, that's what it is. Okay, next one. Next one is, okay. Okay, what happens in a patient with photoaging? What is photoaging? Okay, photoaging. Okay, so you have okay. So this is not a proper question. I'm going to skip out on this one. Instead, I'm going to talk about epidermolysis. Epidermolysis bullosa. Have you guys heard of epidermolysis bullosa? What is the main problem with epidermolysis bullosa?
Hemidysmosome, auto antibody, like antibody against hemidysmosome,
Epidermolysis bullosa. Okay.
or is different?
Okay, so this is not pemphigus vulgaris or bullous pemphigoid. This is a bit different. So what happens over here is there is mutations in epidermal and epidermal adhesion complex. As a result, you have impaired assembly of keratin into filaments. Assemble that. So epidermolysis bullosa is a mutation in epidermal and dermal-epidermal adhesion complex, and for which you have impaired assembly of keratin into filaments. Okay, so that's what it is. Okay, right, that's what it is. Next one. Next one is what is the condition? What is the diagnosis of the patient who has monoarthritis? Monoarthritis, sterile joint fluid aspiration with history of diarrhea. Okay, go. This should be easy. What is the name of this condition? History of diarrhea and arthritis. Anyone?
Reiter syndrome.
There we go. Okay, good. Okay, and who was the doctor who answered this question? I guess Dr. Adhanom. Adhanom. Okay, perfect. Okay, I was wondering where you were, Dr. Adhanom.
Yeah.
Thank you so much for answering this question. And the next one is, what is the name of the condition in which there is joint pain with P and K positive? Okay, very broad spectrum question. Joint pain with P and K positive.
Whipple disease or
Whipple's disease is not the one. Anything else? Where are the
Churg-Strauss syndrome.
Churg-Strauss or eosinophilic granulomatosis with polyangiitis. Okay, Churg-Strauss is known as, nowadays, it's not called Churg-Strauss anymore. It's called eosinophilic granulomatosis with polyangiitis. Okay, and once again, P and K is anti-neutrophil myeloperoxidase. Please remember, P and K means anti-neutrophil myeloperoxidase, and P and K stands for peripheral anti-nuclear cytoplasmic antibody. Okay, peripheral anti-nuclear cytoplasmic antibody. Okay, next one. Next one is okay. Osteogenesis imperfecta. Okay, which type of collagen is underproduced?
Type 1.
Imperfecta. Underproduced production of type 1. Okay, good. Okay. Osteoarthritis. In osteoarthritis patients, what you get is you get pain with crepitus. Okay. Then there's interleukin 6 production. Okay. Interleukin 6 production. Along with that, you have macrophage chemotactic protein 1. Okay, and you also have fissuring, flaking of erosion of articular cartilage. Okay, that's what it is. That's exactly what's happening. Okay, next one. Who knows about McCune-Albright syndrome? Who knows about McCune-Albright syndrome? What is McCune-Albright syndrome?
It is an example of mosaicism.
Very good answer. It's an example of mosaicism, and the problem is there's a mutation in GNAS gene. Okay, we'll talk about this in the future. Do not worry. What happens is there's increased in G protein accumulation. As a result, what happens? You have a triad of precautious. Anyone? Then
Unilateral cafe or spots.
very good. Allied cafe allied spots. Okay, cafe allied spots. Okay, next one. Next one is the last one. Anyone? Polyostatic fibrous dysplasia. Okay, so next time you come across a patient who has spots on their skin, which looks like cafe or cafe outlet spots. By that, I mean the spots that occur in some coffee drinks. Along with that, the child has precocious puberty, early signs of menstruation or growth of pubic hair, and the child also has fibrous dysplasia of one or two organs. This condition is known as McCune-Albright syndrome. Okay. Okay, Duchenne muscular dystrophy. What is Duchenne muscular dystrophy? What happens?
It is an abnormality in the structural protein of dystrophin.
Correct. So there's loss of dystrophin on. Does anyone know the chromosome number? Anyone? Short arm or chromosome number 21, chromosome P21. Okay. As a result, what happens is dystrophin is a skeletal muscle protein which adds cytoskeleton to dystrophin protein. As a result, you have decreased dystrophin myonecrosis and fibrofatty replacement. And in this patient, you have Gower sign, which is positive. Okay, you have Gower sign positives. Okay. Okay. So is it okay if I keep the lecture up to here? Okay, because to be honest, it's a bit exhausting for everyone with the neurology you all know have already left. Okay. Okay. Keep the lectures up to here. I will upload this information in our Facebook discussion group, and from tomorrow onwards we will see if we get some time to do our regular questions, 5 questions a day or not. Okay. Okay, so let's keep the discussion up to here for today, and tomorrow hopefully at 9 a.m. once again we will meet and we will start our regular lectures from neurology. Is that okay?
Can I just ask a small question?
Of course. What is your question, please?
Between the cerebellum and basal ganglia, can I say that the cerebellum is preparing like the movement and the basal ganglia is conducting the movement? Or
No,
did I
modifying the movement?
Sorry, one more time.
So cerebellum and basal ganglia, they're both involved in modifying the movement.
Okay, so both to the okay, understand. Okay, thank you.
No problem.
Yeah, thank you.
Okay, perfect. Okay, so that's what it is. If anyone has any more questions, please let us know in our page and we would like to answer them. And for today, what we would like to do is we would like to take our leave right now. Okay, we will send you the lecture links again by tonight, and please try to do the UL questions with neurology every day. This will help you, and let us know if there's anything else we can help you guys out with. Okay. Having said that, hope you guys have a great day today, and let us know if you have any questions or concerns, and see you guys tomorrow at 9 a.m. Okay. Okay. Thank you.